1+ signal to noise ratio. And all our efforts to increase the capacity are restricted earlier to the factor of the bandwidth or to the factor of the signal to noise ratio. But the 5th generation system is trying to modify this Shannon's capacity equation just by adding few of the terms, which you can see in this equation, that C is equal to D into W into M log of 1+ signal to interference noise ratio. Now, what are these additional parameters? They lead to give you new different technical directions for the 5G. And we observe there are 3 major technical directions for the deployment of the 5G. One is focusing on D, that is the number of access points, W, that is the bandwidth, and M, that is the number of antennas. So if I look at the first parameter, say bandwidth, then I can observe one technical direction, that is the extension of the spectrum. Earlier, we used to use 700 megahertz or 800 megahertz or even 900 megahertz for the 4th generation systems. Now we need to switch on towards microwave, from microwave to millimeter wave. And we observed in the deployment of the 5G, we have the applications of millimeter wave. So higher the bandwidth, you can increase the capacity of the system. So that's why increase extension in the spectrum is one of the direction we observed in the research of the 5th generation systems. Second parameter is focusing on number of access points. No doubt, if I go on increasing the value of D here, my capacity will increase. And to increase this number of access points, we are focusing on small cell network. Presently, a cellular structure of 3rd generation or 4th generation is trying to cover an area of around 5 kilometers radius, 4 to 5 kilometers radius. We are thinking about small cells. We many research articles will find out on the concepts of picocells, microcells, and this pico and microcells, they are basically intended to increase the number of access points. And if the number of access points increasing, they definitely increase the capacity of my system. So another direction is small cell network that I observed in the deployment of 5th generation. Third most important parameter is number of antennas, that is M. And we came to understand the concepts of multiple input, multiple output systems, that is MIMO systems. And from MIMO, what we target in 5th generation is the concept of massive MIMO, where large number of antennas, they have been deployed on the base station in order to increase the capacity of the system. Not only the capacity, the quality of the communication. Also, we can use the technology called as massive MIMO. That increase in M will also boost the value of C. Another very important parameter, which is focusing on the last parameter, that is signal to interference noise ratio. Because whenever you go for a small cellular network, whenever you go for a massive MIMO, the interference is going to create a major role, and we need to work on the mitigation of the interference. So all these 4 parameters, they are going to lead some 3 different technical directions for the 5G. And we observe in the deployment of the 5G, all these technologies, they have been deployed by many of the countries. Then we will talk few things about what is 5G and beyond. In a simple way, if I want to define the vision of the 5G, we can define in the simplest way for a layman purpose. Information is at your heart. Everything is at your fingertips. And we observe the Internet of Things, the Internet of Everything rather than, has been defined in the 5th generation system, and where everything is at your fingertips. Whatever information is at your heart, you are trying to put it on your fingertips by using a variety of wireless devices in the 5th generation. So 5G basically intend to give the information exchange with respect to Internet of Everything. So everything on Internet, we are trying to put it, and that's the reason why our requirements of higher data rates, requirements of higher bandwidths, they are going to be there in the 5th generation. If I just look at to the recent release of the 5th generation, the 5G release 16, it also proposes a very new technology rather than it's a just integration of two existing technologies. It is called as non-terrestrial network, or NTN. Now, NTN architecture, it proposed the integration of satellite communication network and the cellular network, because still 4G, our cellular network and satellite network, they are operating independently. If we could able to carry out the integration of these two networks rather than the integration of many such networks, then we can target the non-terrestrial networks. And the release 16 of the 5G is trying to discuss something related to this integration. But we can understand the difficulty in the interface mechanism, and still the research is going on in this particular integration. The communication capability and efficiency can hardly meet this ubiquitous connectivity requirement after the 10 year. And that is the reason why we need to go on integrating many such sort of networks together in order to achieve the requirements of the ubiquitous connectivity. So this is what something happened beyond 5G in the latest release of 5th generation system. Now we will focus something on 6G. What will be the different thing in 6G? What are the technologies, or what is the aims, the vision of the 6G that I will try to cover in 1 or 2 slides. So if I look at once again the fundamental vision of the 6G, 6th generation system, is wherever you think, everything follows your heart. So something we are talking about following your heart, and whatever you think, you should be able to implement it. So we are talking about the intelligent connectivity. Till 5th generation, we have not much thought about the intelligent connectivity, and that is the reason in the 6th generation system, the focus is been given on intelligent connectivity. Now, intelligent connectivity, we can classify or we can implement by 3 different aspects. One is called as deep connectivity, where we can use the concepts of artificial intelligence such as machine learning, deep learning, deep sensing, deep mind, or telepathy. Telepathy, we can imagine, we have seen in the history the examples of the telepathy, but through intelligent connectivity, we can also do a deep mind or the telepathy kind of implementations. Second aspect of the intelligent connectivity is the holographic connectivity, where the focus is on augmented reality or virtual reality or pervasive computing. We heard these words since so many years, but now it's the time to implement these technologies in the 6th generation systems for ultra high fidelity concepts of augmented reality and virtual reality. Then the third aspects of the 6th generation is the ubiquitous connectivity, which I have talked in my earlier slide also. Ubiquitous connectivity is focusing on connection anywhere, connection everywhere. Now we want to integrate the networks of air, space, ground, and sea together. At this point, we have underwater network differently. We have cellular network, we have satellite network. Let us try to carry out the integration of all these networks in order to carry out an intelligent connectivity. So the concepts of ubiquitous connectivity is one aspect in the thought process of, or in the vision of, the 6th generation system. Now this is a quick comparison of performance metrics, because being a researcher in the wireless domain, we should look at to this performance matrix very clearly, that they are defining the expectations of the 5th generation and the 6th generation systems, and our system should try to satisfy all these performance metrics. What we expect? We expect a peak data rate of 20 Gbps in 5th generation and around 1000 Gbps in 6th generation. The user experience data rates, 100 Mbps is the expectation in the 5th generation, where 1000 Mbps we can focus for the 6th generation. We also want more and more connection density with 10⁶ devices per kilometer to 10�7 devices per kilometer, because device to device communication or machine to machine communication is going to be another technology expected in the 6th generation systems. Mobility support from 500 km per hour to 1000 km per hour in 6th generation system. Area traffic capacity from 10 megabits per second per meter square to 1000 megabits per second per meter square. Latency, I have already talked, 1 millisecond expected in 5G, whereas 0.1 millisecond is the expectation in the sixth generation system. Reliability, very close to 100% that we want. Positioning accuracy from 1 meter to 0.01 meter in fifth generation and 0.0001 in the sixth generation. No doubt we want higher spectral efficiency from 30 bits per second per hertz to 60 bits per second per hertz in the sixth generation system, and the network energy efficiency from 0.01 joules per bit to 0.001 in the sixth generation. These are what our expectations or the as far as the performance metrics is concerned. Now we need to think about the technologies which can satisfy this particular performance matrix in true sense. Now, there are some of the challenges that you can look at in the sixth generation system, the research areas I can say in broad way that you can start your research in the multi-band ultra fast speed transmission, where the focus is terahertz band, and a lot of research is going on in a terahertz band from 0.1 to 10 terahertz. Even the visible light frequency band is also been considered for the multi-band ultra fast speed transmission. Another very important area is the energy efficient communication, where no doubt we need to focus on the energy aspects of the communication and concepts of energy harvesting, the wireless power charging. All these are some of the important areas related to the energy efficient communication. No doubt the most important part for intelligent communication is the artificial intelligence. The artificial intelligence in terms of operational intelligence, in terms of service and environmental intelligence, and it is going to play a key role as far as the sixth generation systems are concerned. Another aspect or another area where you can work on the high security, secrecy, and privacy, because more and more integration of the devices, more and more focus will be on the security aspects, where well integrated multi-level security systems you need to devise, and the technology such as blockchain you can use along with the artificial intelligence for the high security, secrecy, and privacy in the sixth generation systems. So these are some of the research areas where one can work for the sixth generation system. Now I'm coming back to my topic where I need to discuss some of the concepts related to the artificial intelligence and its application in the domain of wireless communication. So those who are quite beginner, for them, a brief definition of artificial intelligence, it is also called as machine intelligence, is an intelligence displayed by machines in contrast with the natural intelligence. We heard this word artificial intelligence since last almost more than 70 years, where we try to put a natural intelligence inside a machine, and we have heard the subjects such as neural network is trying to carry out the concepts of artificial intelligence. So what the intelligence the human is having, we want to put inside a machine, and artificial intelligence is trying to carry out this particular aspect. So what is the scope of artificial intelligence research in broad? If I focus on this diagram, I can deploy artificial intelligence for reasoning purpose, for knowledge presentation purpose, for planning, for machine learning. Machine learning is a recent application of the artificial intelligence, or recent technology of the artificial intelligence. Along with that, natural language processing, perception, motion and manipulation, and you go to any domain, even beyond wireless communication, almost every technological domain nowadays need the implementations of artificial intelligence. From artificial intelligence, if I focus on the machine learning, we can understand there are a variety of categories in the machine learning, such as unsupervised learning, semi-supervised learning, supervised learning, transfer learning, and reinforcement learning. In my latter slides, I will also give some focus for the beginners who are completely unaware about this type of learnings, and not only the focus, but which particular machine learning technology you can use in what applications of wireless communication. That also I will cover in my later slides. But this is just trying to, this diagram is trying to give you an overview how artificial intelligence you can deploy by using variety of machine learning algorithms. Some of the algorithms are also highlighted over here for unsupervised case, such as k-mean clustering, mixture models, autoencoder, supervised learning, such as decision tree learning, deep neural network, support vector machines, and for reinforcement learning, Q learning, historical based RL, or actor-critic learning. I will also discuss some of the recent research papers regarding the deployment of artificial intelligence to the domain of wireless communication in the latter part of my presentation. So if I look at the history of the artificial intelligence, as I mentioned, it's quite old story, which begins in 1956 with the innovations by Alan Neville, Herbert Simon, and Cliff Shaw, who has debuted the logic theorist. And from 1956 till 1980s, people are aware about the artificial intelligence, but the early artificial intelligence was still required the excitement, and that true excitement came into the picture after 1980s, when the concepts of machine learning begins to flourish. So with the help of the machine learning, the artificial intelligence tried to find out many applications in the wireless domain as well as in all other domains of the technology. Recently, after 2010, with the concepts of deep learning, a major breakthrough happened to the artificial intelligence, and now we observe there's a big boom for the artificial intelligence with the help of this machine learning and deep learning technologies. And that is the reason where everywhere we are deploying the concepts of artificial intelligence in our technology. Now, these are some of the applications of the artificial intelligence as far as the wireless communication domain is concerned. You can find out in all sort of communications. The networking part, I will also discuss in all 7 layers of the network architecture. We can deploy the artificial intelligence. Artificial intelligence, no doubt, is used for pattern recognition, for computer vision, for voice recognition, natural language processing, NLP, statistics, data mining, and many such applications are there for the artificial intelligence. Now, if I'll just look at a fundamental difference between the intelligence, artificial intelligence, and how it happens through learning, because learning is the prime part of implementation of artificial intelligence. Systems that think like humans and systems that act like humans is the expectation of the artificial intelligence, and we can achieve it through learning part by deploying systems that think rationally and systems that act rationally. If you look at the picture which is shown in the slide, which will try to address the variety of problems as far as the machine learning deployment in artificial intelligence is concerned, that we can deploy machine learning for the classification problem, we can use it for clustering problem, we can use it for regression, we can use for dimensionality reduction, and in all these aspects we can use the machine learning, and some of the examples I will also discuss in my presentation further. So once again, for the beginner, what is machine learning? Machine learning explores the study and construction of algorithms that can learn from and make the predictions on the data. What is the prior requirement? Prior requirement for machine learning, we must have a train model, train the model. So we require some training data, then you can deploy some supervised or unsupervised algorithm, supervised algorithm which are label based, and unsupervised algorithm which are not having any labels. So based upon that, based upon this training data, we are defining a model. The model that we have defined based upon the training concept or training algorithm, we can then use it for testing purpose, where there is a test data. This model will be tested on the data, and we expect some predicted output at the output of my machine learning algorithm. We find the applications of machine learning almost in every area in today's social media, like the Google platform, YouTube, Facebook, everywhere you find so many applications of the machine learning and artificial intelligence. When we make a search on any Google platform for any particular device, immediately whenever you switch on to any social media platform, you will try to get the advertisement of what you search on the Google. That is one of the simple application of artificial intelligence. You can deploy it for text and language, speech and audio, climate change, geological data, relational data, social networking, as I mentioned, product recommendations on all the websites such as Amazon, Netflix, eBay. Everywhere, people have already started the implementations of artificial intelligence and machine learning. What is deep learning and how it is different than as compared to machine learning? Deep learning is a neural network with one or more hidden layers. So if we look at the problem of the machine learning, you have input parameter, you have output parameter, there is no hidden layer, and you can just deploy, as I mentioned, by using testing data. You design a test model and directly apply it to the testing data in order to get the desired predicted output. So if you look at the machine learning problem, I can define in the form of classification, in the form of clustering, where you can easily identify your labeled data or unlabeled data, categorize them. But in deep learning, the task has been carried out by many hidden layers. You can see one of the example that I would like to identify the image, the animal in the image, or the species in the image. Then I can deploy the deep learning with variety of hidden layers, and then I can predict what the image is saying, whether it is a cat or a ladybug or a dog, and you can write a deep learning algorithm. So it's a more complex term, but can give a more accurate prediction, and that is the reason people started working deep learning along with the machine learning. These are some of the applications, no doubt in detail I'm going to discuss, but as far as artificial intelligence deployment for wireless communication is concerned, we can implement artificial intelligence for big data and complex networking in wireless communication. We can have AI-enabled technology and applications for the connections to the multiple devices, or the integration of the multiple devices in the wireless network. Massive MIMO, no doubt required artificial intelligence deployment for random selection of the beamforming sort of concepts. User central scheduling is also deployed by using artificial intelligence, and new applications which are trying to implement the human reactions. So the human reaction times, if I want to reduce, we can deploy there the concepts of artificial intelligence in this domain of wireless communication. Now, when I focus on machine learning, I mentioned that we could have 4 different aspects of the machine learning, which we can categorize as supervised machine learning and unsupervised machine learning, along with the continuous and categorical classification. So if I focus on unsupervised learning, where your data does not have labels, you can use this unsupervised learning for clustering and dimensionality reduction, where the algorithms such as singular value decomposition, principal component analysis, k-means you can use. There are a variety of algorithms, but specific that I tried to mention here for clustering aspects of unsupervised machine learning. If you focused on supervised, the regression algorithms such as linear regression, polynomial regression, decision trees, random forest, they can use for the deployment of supervised machine learning algorithms in a continuous part. In the categorical, you have association analysis, hidden Markov model for unsupervised case, and for supervised case, you have classification problem. The classification problem you can deploy by using k-nearest neighbor algorithm, trees, logistic regression, Navy Bayes, SVM, support vector machine. These are all variety of algorithms. I'm just trying to summarize in this particular slide. At this moment, you may not understand quietly, but I'm trying to show you in my next slides for which particular wireless communication, what type of machine learning algorithm we should deploy or we observed to be used in recent research articles. So if I look at the key implementations of machine learning, I have already discussed this part, but once again, repeatedly, we must have a training data. Training data, as I mentioned, we can categorize as a labeled data or unlabeled data based upon supervised learning or unsupervised learning. Then we carried out a feature extractions from this training data in order to define a learning function with some equations, say y is argument max of f of xi. This learning function is your trained model, and this model then you can apply it for the real life data in order to carry out the process of prediction, and based upon that prediction you can recorrect your training model. So that is what general methodology for the machine learning. Now, where the artificial intelligence or machine learning is used for wireless communication, a layer approach. If I just focus, if you are interested or if you are working in physical layer, you can use machine learning for end-to-end modeling. For auto encoder, we understand the concepts of adaptive modeling, adaptive coding. They are become more famous as far as the physical layer implementations are concerned. So there also you can use machine learning and deep learning concepts at physical layer. So replace all your mathematical models with machine learning in order to give the adaptive performance or the faster performance at physical layer. If you focused on MAC layer, the RL enabled autonomous decision making, because the most of the decision making part, such as resource allocation or the federal eco-state learning, that we want to carry it out at the MAC layer, and this autonomous decision making is possible by using artificial intelligence for predictive resource allocation for federated eco-state learning. If you focus on network layer, then you will find out the machine learning enabled quality of service optimization techniques by using the deep neural network or machine learning concepts. So centralized deep neural network you can use for optimization of the handover. Whenever you are operating on small cell network, the handover is very important, and if you want to optimize the handover, you can have a centralized deep neural network at the network layer. Similarly, for multi-hop cellular networks, you can deploy the machine learning enabled best quality of service optimization concept for network layer. If you focus on application and transport layer, you will find out the intelligent internet of intelligent things. Now we are talking about internet of things, then internet of everything's. Now with the help of artificial intelligence, what we need to focus is intelligent internet of intelligent things, and that has been possible with the help of artificial intelligence. So ML as a service for personalized ML models, for opportunistic networking, for client-centric networking, for all these applications. And in the application and transport layer, you can use the concepts of artificial intelligence and machine learning. So some of the novel services you can focus for the research, such as XR and holography, or autonomous driving, or massive robotics, where in large sense for the communication purpose also you will find out the machine learning and artificial intelligence. So this is what quick overview of at what layer, which layer you can use. Almost you'll find out every layer of the network. You will find out the implementations of machine learning, deep learning, and artificial intelligence. Now I'll try to give you some more techniques where you can deploy machine learning at physical layer primarily, more focus on physical layer and few aspects on the higher layers. So if I focused on physical layer, the deployment of machine learning or machine learning driven physical layer, as I mentioned, you can use it for channel coding, where the applications of adaptive coding you can deploy by using machine learning concepts, synchronization, positioning, channel estimation, and beamforming. One of my PhD student is working on the concepts of deploying machine learning for beamforming. My another student is working on channel modeling and channel estimation deployment for machine learning in the wireless physical layer. What we observed recently, deep learning is also a powerful technique for designing, enhancing, and optimizing one or more multiple functions in the physical layer for sixth generation system. So as far as physical layer is concerned, you will find out a lot of applications of machine learning. Now, just I mentioned one example of the deployment of deep learning for channel coding. This is the reference taken from one of the research article where a complex problems of channel coding, they have been deployed by using deep learning. The concepts of reinforcement machine learning is mostly suitable algorithm to solve the channel coding problem, and you will get many research articles which are implementing the reinforcement machine learning for the adaptive channel coding or for the various aspects of channel coding problems. One such sample example is been shown in this particular diagram, where you have information bits given to the encoder, then that encoded output is given to a deep neural network, where training carried out through a neural network and so many deep hidden layers which will try to make a prediction of which sort of channel coding technique I can prefer for a suitable channel or for a suitable transmission system. This is a summary of variety of machine learning algorithms used for channel modeling purpose. I observed in the literature there is a ML algorithm based upon radial basis function, which is used for prediction of the path loss required for channel modeling. Relevance vector machine is another algorithm which is used for estimation of direction of arrival for MPCs. RVM is another algorithm which is used for filtering of the noise embedded MPCs to determine the PDP. Then artificial neural network, ANN and PCA, to remove the noise and estimate the CIR, because channel modeling is the most important part in the deployment of any communication system. And for that channel modeling, you need to find out the path loss, you need to estimate the channel parameters, and you can use variety of machine learning algorithms for the channel estimation purpose, such as one more is multi-layer perception. MLP is used for predicting the outdoor received signal strength at the receiver. Convolutional neural network is used for exact channel features and identification of different wireless channels based on channel measurement data. Lasso is another machine learning algorithm. SVM, support vector machine, is used for predicting the path loss, and K-means or FCM is used for clustering and tracking of the MPCs. So a variety of such algorithms you'll find out in the different research articles published recently. I just try to summarize them as far as the application is concerned. So depending upon in which area you are working, you will find out some applications of machine learning algorithm related to that area. This is a brief about channel modeling. Then if I look at the synchronization aspect, you will find out a deep learning neural network technology widely used for the synchronization purpose, where signal separately from signal detection and decoding, because detection and decoding is basically based upon the synchronization. And whenever you will go on implementation of multiple users concept in the wireless communication, you will find out the synchronization is a very tough job, and that synchronization part you can make it little simple by using the deep learning neural network technologies. One sample example is showing how you can use deep learning for the synchronization purpose. This session is just to give you a brief idea where you can implement artificial intelligence in the wireless communication domain. However, if you found some research interest in that category, you can just excel your research by referring this particular presentation in future. Apart from that, deep learning you can also use for positioning purpose, and you will get deep neural network learning location based technology suitable for positioning with adaptive technology to adapt to the actual environment and to solve all the positioning related problems. One such example is being deployed where Wi-Fi signal, Bluetooth signal, which has been given as an input to the input layer, and which will try to address some of the issues related to the positioning part. Then you can also use machine learning algorithms for channel estimation. So for channel estimation, you can look at, it provides the information about how the channel distorts the transmitted signal. Deep learning based channel estimation can be optimized through the training data of neural network despite the complicated channel environments. We understand for almost all implications of the quality aspects, quality of service parameter, the major or the most important thing is the estimation of the channel, without which you cannot deploy the massive MIMO in the 5th generation. You cannot deploy the adaptive coding technique or adaptive modulation technique. For everything, what we require is the estimation of the channel. And there are a variety of research carried out in the channel estimation part by using machine learning and deep learning. You can focus on this aspect also by deploying the concepts of artificial intelligence for channel estimation. Another very important aspect where one of my PhD candidate is working is the optimization of the beamforming. The deployment of massive MIMO concept, where large number of antennas we are putting on the base station, but we don't have the enough RF chains, because if you want to put the number of RF chains exactly equal to the number of antennas, the space, the size, the cost, everything will go on increase. So we want optimum number of RF chains to select the best antennas out of whatever the antennas having for MIMO. Apart from that, if you want to target the multi-user applications, efficient beamforming techniques you need to deploy. Not only efficient, but the intelligent beamforming techniques you need to deploy by using smart antenna solutions, and that is required in order to achieve the features such as stability of the throughput, reduce sensitivity to interference, extended coverage, to enable the high mobile applications, and to reduce the energy consumptions. Everywhere we require an intelligent beamforming, and to carry out that intelligent beamforming, the neural network module is helping us a lot. A deep learning can represent this optimal solution to support the adaptive and real-time massive MIMO beamforming. So you will find out lot many papers which are used the concepts of deep learning for optimization of the beamforming, and either they are focusing on the energy consumption parameter or on the other quality of service parameters such as bit error rate or throughput or the sensitivity to the interference mitigation. Everywhere the intelligent beamforming is helping you to improve the quality of service parameter with the help of deep learning concepts. Now, next to that, you can use ML for higher layers like MAC layers for orientation and mobility predictions in wireless virtual reality networks. So one of the algorithm is available in the literature, that is Federal Eco-State Network Prediction Algorithm. You can use for the mobility predictions in wireless virtual reality network. Similarly, predictive resource allocation in machine type communication, you will find out some of the algorithms, some of the techniques, rather than we are earlier using the orthogonal multiple access, but the people are now started using the concepts of non-orthogonal multiple access called as NOMA in massive MIMO and in cell-free massive MIMO for predictive resource allocation using machine learning algorithms. This is another research area where you can work for the MAC layer, deployment of the MAC layer. Apart from that, predictive power management. So those who are working in the domain of energy efficiency or energy conservation, they can also use the machine learning techniques at MAC layer for predictive power management applications. Another area is asymmetric traffic accommodation, because we need to understand the traffic patterns and the network activity data at the MAC layer, and you can use the machine learning based algorithms to increase the system performance for based on the traffic pattern and network activity data in the asymmetric traffic accommodation. Then still, if I want to go for higher layers, the machine learning for 6G network performance management automation. So now, the network performance management, you can carry out the automation to enhance the performance of coverage throughput, quality of service prediction, automatic network configuration, power control, operational maintenance, fault maintenance. All these are the parameters related to the network power performance management automation. In the 6G network, you can deploy the machine learning aspects. Apart from that, ML aided UAV control. So by using the ML, the reliability, safety, and energy consumption of unmanned aerial vehicles, because recently a lot of research is going on unmanned aerial vehicle, where you can use the concepts of machine learning for controlling purpose. Apart from that, opportunistic data transfer in vehicular network. So by use of ML technique, we can increase the traffic safety and efficiency in the vehicular network. If I'm talking about still the higher levels, software development aspects, there also you can use many concepts of machine learning. These are some of the broad research areas where you can work for the deployments of artificial intelligence or machine learning in the wireless domain. If I just focus further on the ML for network performance case, I hope the things are visible.
Yes, sir.
Okay. So this is just an overview of ML for network performance, where you can use the artificial intelligence for 6G mobile network for enhance performance, AI managed mobility, user behavior localization and traffic, better deployment, where you can deploy it for SDN, ANR, small cells topology, network security assurance for analyzing massive data, which will enforce the threat detection, for improved network efficiency, for resource utilization, admission control, congestion control. So the sky is the limit for the deployment of the machine learning, because you can find in every layer of the network topology the deployments of machine learnings are there. Now, in the next part of my presentation, I will just try to give you the insight that for which type of applications of wireless communication we can deploy which type of machine learning algorithm, that is supervised or unsupervised, where to deploy supervised, which sort of applications they require the regression problem, the classification problem, the clustering problem, and which are the suitable algorithms deployed for that particular application, that we are going to cover in the next part. This is once again a repeated slide, because now I want to focus on supervised machine learning, unsupervised machine learning, and all the aspects of this machine learning from wireless communication point of view. As I mentioned, what is supervised learning? Supervised learning, it refers the task of inferring a function from a labeled training data. Whatever the training data, whether it is in the form of text or a document or an image or a sound, we have labels. We can categorize that data. A data related to one particular label we can categorize together, and based upon that label we carried out the feature extractions. The extracted feature vectors along with the labels, they are given to a machine learning algorithm in order to define a predictive model, and then that predictive model is being tested for the real life data related to the text, document, image, sound, and then we will try to predict the expected label for whatever the real life data that we have with us. This is in short called as supervised learning. Now, where the supervised learning required for wireless communication, if you find out the applications of channel estimation, most of the times our data is a label data. Training data is a label data, and you can use the supervised machine learning for the channel estimation. Similarly, at the receiver end, you need to carry out the signal parameter estimations, and for that signal parameter estimation also, most of the times your data is a labeled data, and you can use supervised learning for there. Apart from that, user location prediction. Now, a lot of research is also going on for user location prediction, and that particular application you can categorize as a supervised learning, and you can use the concepts of supervised learning for user location prediction. This is one of the research article reference rather than a paper published in 2016. You can find out the references given over here, which is focusing on the deployment of supervised learning for parameter estimation using deep neural network. So an effective deep neural network model has been proposed in this particular paper, which uses the concepts of signal asynchronous delay tap plot. Why I'm showing all these particular things? Because my intention is not to discuss how DNN is used for parameter estimation, but to give you some insight that some research, recent research articles, which are focusing on these applications of parameter estimation for deep neural network. So this is one of the model which is proposed in the paper, which will try to estimate, will try to find out the higher accuracy for SNR estimation with low speed and asynchronous sampling, that has been proposed by using deep neural network in this article. Apart from that, you will find out one more article which is focused on the channel estimation using deep neural network, and estimation and symbol detection. Both the concepts has been carried out in this paper by using two hidden input layer architect of deep neural network, where the focus is given on deep learning with ideal conditions, deep learning with all the effects, and MMSC with all the effects by implementing deep learning in the paper published in IEEE wireless communication letter on power of deep learning for channel estimation and signal detections in OFDM. Similarly, the algorithms such as support vector machine, SVM, you can use for the localization detection, for the prediction of the localization. So an effective support vector machine based approach has been discussed in this paper for predicting the user's next cell. So you can see the deployment of the deep neural network, the learning algorithm, the train classifiers, and all these aspects, they have been deployed in this paper for handover kind of applications. So handover information you can use here by using support vector machine. So these are some of the things related to the supervised learning. If I focused on unsupervised learning, the concepts of unsupervised learning, where the training data is not a labeled data. So you cannot categorize it, you cannot label it. So it refers to the learning task of inferring a function to describe the hidden structure from unlabeled data. So directly the feature vectors have been, the features have been extracted from the training data to design a predictive model by using machine learning algorithm, and then we will try to find out the likelihood or cluster ID or better representation of that particular data. So in all such applications, we generally use, wherever there is unlabeled data, we use the unsupervised learning. Now, where we require in wireless communication, the applications of spectrum sensing. So spectrum sensing is required in almost every part of cognitive radio, because without spectrum sensing, cognitive radio is not possible. And this particular category, it comes under unlabeled data, and we need to require unsupervised learning for spectrum sensing. Nowadays, for device-to-device communication also, we require spectrum sensing techniques, and there also you can use the unsupervised learning for the spectrum sensing. Signal detection, base station clustering, these are all the applications where generally the data available is unlabeled, and you need to deploy an unsupervised machine learning algorithm over here. This is one of the paper is showing the deployment of K-mean algorithm for spectrum sensing. So an effective K-mean model for cooperative spectrum sensing in cognitive radio network is been used by using unsupervised K-mean algorithm for the classification problem.
Hello, sir.
Yes, ma'am.
Slides are not changing actually.
They are not changing.
Yeah, ML for network performance management च्या इथेच slide. तीच slide
Okay,
दिसते.
okay. I'll just stop my sharing once again.
Yes,
Can you able to see now?
yes, sir. Yes, sir.
Is it changing now?
Yes, sir. Yes, sir. It is changing.
Okay. So this is the part I think I missed out because of the sharing. I'll just try to show it to you. I was discussing about the machine learning supervised and unsupervised. I have discussed the supervised learning and its application to channel estimation, signal power parameter estimation, user location prediction. Then some of the examples that I have told for supervised learning. The algorithms and their implementation, then unsupervised learning, where the concepts of unsupervised learning, they are deployed for spectrum sensing, signal detection, base station clustering. Then K-means in spectrum sensing, the deployment of K-mean algorithm for unsupervised learning in spectrum sensing that I covered. Encoder is another application in MIMO OFDM network. You will find out some of the research articles where we have used the unsupervised machine learning algorithm for the applications of autoencoder. Now, apart from supervised learning and unsupervised learning, there is one more type of machine learning algorithm that is called as transfer learning. Now, what is transfer learning? Transfer learning is a research problem in machine learning that focuses on storing a knowledge which is gained while solving one problem and applying it to a different but related problem. Now, where we require the transfer learning we required in wireless networking, such as base station switching. For example, my base station has acquired a sufficient knowledge about the network, about the device, about the user. We can transfer that knowledge from one base station to another base station during the process of base station switching. So that is what the implementations of transfer learning from one model to another model, and we can use it in base station switching, we can use it in spectrum management, we can use it in cache placement also. So this is another implementation of transfer learning. You will find out the application of transfer learning in green random access networks, which have been proposed in one of the article published over here. We're transferring the learned base station switching strategy in former period to the current period. So one of the base station which is operating will try to deploy their own concepts of machine learning, will try to get a complete knowledge of the user about the channel, and whenever the switching happens from one base station to another base station, this learned knowledge is being transferred by using transfer learning mechanism. So these sort of applications we can target by using transfer learning technology. This is another article focusing on the contributions of transfer learning in green RANs. Apart from that, teaching learning in spectrum management, there also we can use the concepts of transfer learning. This is another paper which is focusing on the transfer actor-critic learning approach to cognitive radio network, where the secondary users, which is new to CRN, can use the matured experience of the existing expert second users, which have a similar quality of service requirement. Now, in future also, whenever you will go to the small cell network, there this transfer learning is going to be very much useful, because one of the secondary user is already having certain knowledge about the network, and if another user is trying to come inside that network, we will have a transfer of that knowledge, so that the second user need not require to carry out all the process of channel estimation, channel modeling, or to understand the environment of the network. The ready-made transfer of the service, transfer of the parameters which have been understood by the existing user, we can carry it out by using transfer learning mechanism. The last aspect that we can find related to the machine learning is called as reinforcement learning. Now, in reinforcement learning, basically we have some agents. So what these agents are doing, they will try to interact with the environment. So it is an important branch of machine learning where an agent makes interaction with the environment. Agent would like to optimize a long-term accumulated reward by taking a sequence of actions. The agent which is continuously in contact with the environment, it will try to acquire all the knowledge of the environment, will do the optimization, and then that agent will help in implementing the learning, the learning concepts to all the other aspects. That is called as reinforcement. Where reinforcement learning is required in wireless networking, you can use it for vehicular network, because in vehicular network you need to observe certain parameter, and then there is a one-to-one communication carried out between the agent and the environment, and or between agent and the client. So there you require the reinforcement learning. The cloud runs, there also you require this reinforcement learning, and particularly in the device to device network, in machine to machine learning, you require the concepts of reinforcement learning, because they have been controlled centrally by the base station. So some agent will try to acquire the optimization for all the other users. These are some of the examples where the reinforcement learning has been used for by using deep learning for reinforcement learning from non-working to working due to deep learning, which was used in this particular paper. Then for vehicular network also, you will find out the applications of reinforcement learning given in one of the paper which is published in 2017, where they talk about a historical based reinforcement learning approach in vehicular network for base station association in the dynamic environment. This is another paper which is giving some contributions of using the reinforcement learning for vehicle applications on the asymmetric load problem and for uniform user experience with higher service rates. This is some of the example for deployment of deep reinforcement learning for the cloud RAN concept. And as I mentioned, for massive MIMO, we can also use machine learning and deep learning for channel estimation. Basically, channel estimation you require for many of the applications. One of the applications which is shown here for the massive MIMO, where you are using machine learning or deep learning for estimation of the channel, and based upon that estimation of the channel, you may design the beamforming or techniques, or the intellectual beamforming, or the adaptive coding, adaptive modulation, everything you can achieve by making accurate channel estimation of the system. So this is all about a brief or quick overview of my presentation, where I just try to give you an insight of use of artificial intelligence in variety of domains of the wireless communication. You can further explore depending upon your research area or research interest in any of this domain, and try to find out the implications of artificial intelligence in order to achieve the better or reliable communication. So to summarize this presentation, The complexity of the future wireless communication network is making the use of deep learning an indispensable design tool for all the wireless communication applications. Research in this field is just started in last 10 years, but there's a great requirement as far as the sixth generation system is concerned, and you can go on implementing, you can go on exploring in all the possible layers of wireless communication. Few of them I have tried to highlight in my presentation, that if you want to work at physical layer, you can focus on channel modeling, channel estimation, adaptive coding modulation, beamforming. If you want to you are working in MAC layer, you can use artificial intelligence for prediction in wireless virtual networks, predictive resource allocation in machine communication, power management systems. And if you're working in application layer, you can use artificial intelligence for 6G network performance management automation, ML based aided unmanned vehicle control, opportunistic data transfer in vehicular network, and all such applications you'll find out for rest of the layers, network layers, transport layer, and all other layers also. So challenges for 6G is opening a new horizons for the future research detection, and no doubt artificial intelligence, machine learning, and deep learning are going to play a key role in all these particular applications. And in this session, I just try to highlight some of the areas where you can focus for your research work by using artificial intelligence for wireless communication. I hope I try to give a good insight of this domain. If you have any queries, or if you would like to add your experiences over here, the session is open for the discussion. If you have any queries, if you want to discuss, share your thoughts, I feel the forum is open.
Thank you very much, sir. Such a nice and wonderful session. So, any queries from the participants?
Very nice session, Vaibhav sir.
Yeah, thank you, madam.
It was very nice to listen to you, and thank you very much for agreeing and being here for this presentation.
Yeah, I hope there are no questions from the audience.
Yes, sir. There are no questions. So, yes, sir.
Yes, somebody is asking. Yeah.
Yeah, chat box.
Okay, so something related to the reinforcement learning. For wireless sensor network, if your wireless sensor network, definitely if it uses a centralized control, then you can use reinforcement learning over there, because generally all the applications you'll find out, if it is a vehicular network or a device to device network, you need to define certain agent, and you need to carry out the learning mechanism through that agent. So in the wireless sensor network also, you can define a sensing node as your agent, and you can carry out the optimization of the learning environment through this agent, and then you can deploy with the help of transfer learning to all the other sensor networks. So you'll also get many such research articles related to the wireless sensor network. I hope I could able to satisfy your query. I don't have any material to show you for wireless sensor networks at this moment, but you can definitely refer the literature.
Sir, somebody is asking for research area 5G with AI. So I think you have already explained.
Yes. I have already just explained many research areas in the 5G which are using the artificial intelligence. Where will we implement the channel estimation? See, channel estimation is a fundamental thing required in any wireless communication deployment. Just to give an example, if I want to deploy the intelligent beamforming in massive MIMO, now I need to select the antennas for the communication purpose. So on what basis I select an antenna? Definitely I need to look at the channel between my antenna and my receiver, my user. So I need to carry out the channel estimation first So how I'll carried out a channel estimation? I need to send some pilot signals. So pilot based transmission I will carry it out through all my antennas towards the receiver. Receiver will receive the pilot and will try to predict something about the channel. It will try to find out the channel state information. We call it as CSI. So this CSI information will be fed back from the receiver to the transmitter, and based upon this CSI, we will try to understand which channel is best for which particular antenna, and that antenna will be selected for the transmission of the signal. This is one of the simplest application for channel estimation. But you require channel estimation almost for everything in communication. If you want to deploy adaptive modeling, it is definitely based upon type of channel, so you require channel estimation. All the problems related to the physical layer, if you want to address, channel estimation is definitely required, and with the help of machine learning concepts, you can use it intelligently, more accurately, that particular technique.
So there is a few more questions. We can merge these two questions. What is the specific thing in Q-learning if we talk about reinforcement learning? And the same question, I think, can you please explain reinforcement learning? The same question.
What is specific thing in Q learning if we talk about reinforcement learning? I'm sorry, I'm not much expert in reinforcement learning at this moment, but I do not understand the concept of Q learning. So I'm really sorry that I could not able to address your question, because my work was little bit focused on this supervised and unsupervised learning and its application to the wireless communication. I received this information from some of the recent articles which I just try to just present it over here.
Sir, can I ask one question?
Yes, ma'am, please.
Yes, sir, like just now I had asked you that where we'll implement that channel estimation, whatever. So will it be the application specific?
Yes, definitely. It is application specific only, because in all machine learning algorithms, you must require some training data, right? And that training data is definitely application specific. So whether you implement a reinforcement learning or a transfer learning or supervised and unsupervised learning, it is a data dependent system. So what type of data you have for that particular application, based upon that you need to choose a type of algorithm over there. So it is definitely application specific.
Okay, thank you, sir. Thank you so much.
Sir, I think there are no more questions.
Okay.
No, sir. We got one more question.
Yeah.
You can see in the chat box, this concept is new in WSN or IoT. I'm into work in it and studied little about it, but found a few doubts. Anyway, okay, sir, it's just kind of
okay.
Okay, sir, there are no more questions. So over to Annapurna ma'am.
Thank you so much, sir, for sharing us such useful information in the field of 5G communication and how 6G is going to help us in various domains using artificial intelligence and machine learning. It will be really helpful for our participants to explore in this emerging area. On behalf of Silicon family and our participants, I thank you once again for this wonderful session. Thank you so much, sir.
Thank you, madam. And I would like to thank all the organizers for providing this great opportunity to interact with many of the faculties or many of the researchers in this domain. So thank you very much.
Thank you, sir.
Thanks a lot, sir.
Thank you, madam.
I request all the participants to join at 11 o'clock. There is a break for 30 minutes, so we will join at sharp 11 o'clock. Hello, Anish, you are there?
Yes, ma'am.
Hello. Hello, good morning, ma'am. Yeah.
Good morning, good morning. We'll be starting soon. Just 5 minutes.
Sure. Yeah. Sure.
Annapurna madam, Vandana madam, shall we start the session?
Yes.
Okay.
Yes, we'll start.
So I request Annapurna madam, please take the charge and start the session.
Yes, sir. Welcome back to the session 2 of day 4 of our FDP. Without much delay, let's start our session. I take the privilege to introduce you our next speaker, Mr. Anish Sadangi, who is one of our alumni of Silicon Institute of Technology. Let us know him in brief. Next. Anish finished his technical studies in electrical and electronics engineering in 2019 from Silicon Institute of Technology, Bhubaneswar. During his studies, he has been awarded with national awards for innovation and system designs of large-scale IoT implementation. He has keen interest in research and has published his works with major publication houses including IEEE, John Wiley & Sons, and Springer Nature. His works are mostly in the field of distributed systems, big data, data science, product development, and IoT. He is currently working as senior data scientist with a UK-based company Fusion Practices Private Limited and leading data engineering team and creating Azure-based solutions for various clients at scale. He is very passionate about technology and believes in problem solving for society as well as industry via technology. I request Anish to continue the session.
Thank you so much, ma'am. Am I audible?
Yes, you are audible.
Yes, Anish.
Yeah. Thank you so much for introducing, and I hope everyone is well in this session and during this pandemic. I know that it's been a very tough time for all of us. There is COVID, and then we have got the cyclone, which just went through. I hope everybody is fine without much of any kind of loss. And thanks yet again to for inviting me and giving me an opportunity to interact with everyone. And I believe this would be a very interactive session where I can share my experience that I have learned in last 2 years, mostly in the big data side, and some of the IoT data analytics that I have been part of. I'll quickly share my screen if I have. Yeah, I do have. If that's fine.
Anish, if possible, you can switch on your camera or video.
Yep, I will do it. Just give me a second. Sorry for that. Actually, there was a lot of. Yeah, 1 second. Okay. My. Oh, sorry. Am I visible?
Yes, you are.
Yeah, thank you. Okay, so my screen is visible, I guess. I have shared my screen. Please let me know if it is.
Just maximize the screen.
Yeah, absolutely, I'll do it.
Yeah, fine.
Yeah, thank you. My this topic would mostly focus on the cloud side of things, including some of the big data, I mean computation engines that we will see through a demo, and I will also share some of the informations regarding how the cloud technology basically works, what are the key components, and why at all we need IoT coupled with computing at all. Why do we need a computing layer after that we know that IoT is already there, which can create those data sets and generate sensor values out of it. So why at all there is a need of having computation layer on top of it. So we'll go through each of this. I would try to share all of that as much as possible. So briefly, I had divided this into various agendas, why at all we need Azure or any kind of cloud computing platform, why IoT is basically coupled with any kind of computing. Then what are advantages of having a cloud computing, and what are the benefits over having a on-premise system. So we will also talk about a bit about what is on-premise and what is cloud and stuff. There are also various types of cloud and various kinds of offering that any kind of cloud provider basically gives. And we also know that there are major players in this cloud computing space in the market, including Azure from Microsoft, AWS from Amazon, and Google Cloud Platform by GCP. So we will go through it. Before I start, I would like to definitely take questions in between, if at all there is any. I would love to take those, and we can make this session as much as interactive as possible. And definitely we have a demo session, and I would like to spend some good amount of time to share the demo which I have done on Azure Cloud, so that it would give everyone a very good perspective of what we have just talked about and what information has been shared. um Apart from that, most important part from IoT perspective is, I believe, it's data, because IoT is all about generating data at the end of the day, and how we process it, how we keep it, that's really important to take into considerations. um, I would definitely request, if you want to you speak up, raise up your, I guess there is a raise hand feature in Zoom, and please let me know so that I can help you with any kind of answers. Okay, moving on. So first things first is why at all we need computing, if at all we are talking about IoT. So the most important part is, as we all know, that IoT sensors are nothing but some data generating things that are connected via some network, which we call it as internet. And we can have multiple kind of protocols that are there, like Zigbee protocols or LoRaWAN or any kind of other IoT stuff. But essentially what it is doing is that it's generating data, and those data has to be processed somewhere. It needs to be stored somewhere. Like for compliance needs, there are certain various policies and government side laws as well, which guides or complies companies to keep the data within a particular boundary or geographic area. So in that regard, there is a lot of governance, there is a lot of need of storing those data, and also in the best way possible, so that it can be used later on in basically uh, giving some kind of reporting, some kind of analysis, maybe predictive analytics, maybe machine learning that is running on top of that data. So it's very essential for us to keep those data at a very good place. Secondly, there might be the, whenever we know that this data that IoT generates, it's mostly in voltage that we see, and then we convert that voltage levels to a particular values based on the formulas and empirical formulas that comes with the data sheet. But essentially after those data, it needs to be in some kind of format that computer understands. And it's not that we just put in numbers and computer would know that this is a temperature data, or this is a humidity data, or maybe there are other kind of multiple like datas across. So in that case we need to have some kind of structure which defines the data and which tells that this is the data. uh, Sorry.
Pritam, I request all the participants, please mute him. Anis, you may continue.
Yeah, sure, thank you, sir. um so there has to be some structure which defines what data is and what it contains. So to do that we have this complex transformation that goes into bringing out those data sets and also while we keep it, we need to make sure that the security side of having the data is also ensured. So in that case we need to have encryption and decryption technologies as well when we store the data set. Apart from that, we also sometimes use this data, as I mentioned, for machine learning and advanced analytics to report, to understand what kind of geography it is, to understand what kind of life cycle or lifetime that the data may provide. So there are a lot of good advanced kind of algorithms, I would say, that is used. And to use those algorithms, there is a requirement of heavy computation, and there's a requirement of resources that would carry out those algorithms. If we see, artificial intelligence is not a very new thing. It has been there since 1980s and 60s, where people were still exploring on deep learning, and they had all those papers and research published. But the only limitation that people had in having it in real applications was the hardware limitation, because at that time hardware was not capable of handling those humongous amount of computations. But with advent of GPU and more advanced CPUs with multiple cores, now those kind of deep learning, advanced analytics is possible. And that's the reason why today we are seeing this kind of data science boom around the industry. And to drive that all, we definitely need to have a computation where we can perform all those algorithms and have the results. And like I mentioned already, data has to be stored in the best possible way so that it cannot be breached. We every day or so we definitely hear that there is a data breach in some company, and by having that or by doing that, what happens is the company valuation basically decreases. So in that case, company invest a lot in having best security practices. Microsoft itself invests $1.3 billion in terms of R&D of just for the cybersecurity part of Azure cloud. So there is a lot of investment in that regard, and that's the reason why there's a strong importance, and there's a strong technologies around that, which is ensuring when we have data is stored on the cloud, it ensuring that the best security practices and encryption is followed. um, so there is a question between on-premise and that of cloud. So on-premise is nothing but our own laptop can be considered as an on-premise system. We in industry we call it as a local machine, but it is essentially an on-premise, or the servers that we run in the college, that are also on-premise system, because it's completely with your own hardware that you are maintaining. You are taking charge of all the softwares and operating systems that is running on top of the uh, you those hardware machines. You are also taking in charge of the security side of it, and ensuring that all the best practices are met. And if there is any kind of uptown downtime, or any kind of new requirement coming in. It has to be the person who is handling the on-premise data server. He has to add in a new CPU or maybe a new memory, a RAM, what we call it as memory. And or maybe they might upgrade the CPUs as well, like putting a i5 processor or i9 processor that has come on a server side computation. So there might be ample of use cases where there is high level of overhead of maintaining the infrastructure. Each time there is a new um, requirement coming in, there has to be a team who is responding to those news requirements. So there has to be a specialized force that is required to maintain those data centers. And while maintaining it, there is constant requirement of updating your softwares to the best security patches, and in doing so there is a licensing cost involved. So all in all, there is a huge overhead of having a data center of your own or running a server of your own. And also there is a strong compliance that has come into India and across the globe, where data security is essentially really important, because currently there are a lot of organizations who are handling sensitive data, they are handling our maybe name, our address, and many other sensitive data which can uniquely identify us. So there is a strong law which is prevailing around the globe in different names. One of the names in Europe that they use is GDPR, and there is another they use in California, that is CCA compliance. So those kind of compliance are, and recently in India there was this data governance law that was passed. So by all those laws, it essentially governs a particular organization to adhere to those laws by enabling right to be forgotten, or maybe right to export data, or might be right to update data. Say you want to, you have changed your address, and you have to you tell the organization who is handling your PI, like your bank. You can just go and tell them that you need to change my address. So banking system should have such kind of a system which lets you or enables the customer to update their data. Right to be forgotten is not yet implemented in India, but we have worked with my clients in UK, and right to be forgotten is very strongly followed there, where a customer can come in and tell the organization that you wipe out all the data that you have that belongs to me. And the owner or the organization has to have that kind of a technical infrastructure that enables to delete all those PII data or sensitive data, like your name or passport or credit card number, etc. So there's a huge overhead, there's a huge running cost, operating cost, and also a huge time when there is, let's say there's a new requirement. Obviously there will be huge time in procuring your hardware, then implementing it, and then making it up. So there's a huge time to SLA. But to the answer those drawbacks, basically that's where cloud computing came in. It's not that when you expand, you have a let's say a requirement of one particular virtual machine on cloud, but tomorrow let's say you are expanding your team and you want 4 or 5 more virtual machines. So it's not that you need to buy a new hardware component altogether. You can just rent it on Azure or any kind of cloud service provider, and it would be just in some clicks that you can get a virtual machine. So that's the ease of use. You and with the number of clicks you may also get this, that the time to have that particular virtual machine would be very very less. It generally takes it 1 hour or 2 hours to completely provision and ensure all the security patches and give it to in an industry with an industry standard virtual machine to someone. So the SLA time is very high, sorry, it's very low. So that's the reason why the service is very fast. We will see that why cloud computing, but to understand what exactly cloud computing means is nothing but it's a In the very layman term, what I say is it's just a else's computer. Like if I am here sitting here and I am accessing your computer, and you have hosted your computer as a cloud computing server, then that is also possible. That is also a cloud computing infrastructure that you are giving. So essentially, cloud computing is nothing but somebody else's computer, but in a large scale, when we do it, it's data centers that we have. Like Azure have its own data center, Facebook, Google, name it. There are tons of cloud service providers that are around the country, around the globe, who are providing this kind of cloud services. What they take care of is they take care of the entire hardware, the entire infrastructure, the electricity that goes into keeping it up 24/7 into 365 days. They give a uptime of 99.999 percentage, which is roughly a lot to have, and also a very high availability. Like there are very few chances that those data centers would be down. And also, if at all there is a down time in the data center due to some disaster like cyclone or something, then there are other provisions uh, in the cloud service providing provider space, where basically you can keep your data in multiple places across, and at the same time you can fetch those data. And also, in case there is a disaster in one particular data center, you can still use the data because it is replicated in one another data center which is hosted in some another region. We'll look into that in a diagram, so it would be much more understandable. Secondly, economy of scale, because the hardware and all the infrastructure that this cloud service providers implement, that is at huge scale. So when you just take up a space or a pie of that huge infrastructure, the cost is very low. And that's the reason why, as an end user or as a organization who is using cloud computing platform, they get a very cost efficient model of operating their infrastructure. So that's a reason primarily why, and what is cloud computing and why we use cloud computing at all. And like I mentioned, it's less, it costs really less because we are sharing a pie out of the big data center that has a very high level of availability. And in terms of scalability, there is a new paradigm that has come called as serverless, where basically you can deploy your servers into a particular region, and when there is less need, you can scale down your server, and when there is a larger request coming in to process something, then you can scale up. So the best example would be like in big billion days that we see in Amazon, or the Flipkart also has its own big billion days. Sorry, in Amazon there is Great Indian Sale. So in that, what powers their backend engines and what essentially helps them at this particular scale? We have seen the first time when Flipkart launched a big billion day, the server crashed, but because they didn't have that kind of infrastructure to handle all those requests. And in BPUT, we definitely see every now and then that the server crashes when there is a result out. So that's basically because the infrastructure which is powering all those servers are not scalable. And that's a very static scale. I mean, if the limitation goes up beyond the particular server's limit, it is not able to process, and that's the reason why we get a bad error at the end. Similarly, things happen with Flipkart. Billions of users stroke at the same time, at the same point of time, and server was not basically capable of handling those amount of requests. So that's why they failed madly for the first time, but second time they had those infrastructure set and they launched it very well. um, AWS, what it does, they have this elastic serverless technology, which they call as elastic stack. And you can basically have this server which is scalable. Let's say when there is a large number of users coming in and they are hitting that particular request, and like in Amazon, we are shopping something and there are a large number of people shopping at the same time. So so number of servers will basically increase automatically, in the very layman terms. And when there is less people using that server, then the server number of servers will again decrease. So what we get essentially is that we get unlimited computation. Doesn't matter what amount of users come in, the server will automatically scale out, because to incorporate all those number of requests, and it would also automatically scale down, so it also save cost when there is no use of such amount of computation power, because uh, there are certain computation engines which are very costly out there, which are used by this kind of large organization to ensure high level of availability. um, Secondly, we have this enhanced security, like I already mentioned. Public cloud and service providers invest $1 billion in handling those security, also ensuring best practices. Then performance and reliability. We will see how this 99.999 and so on percentage. So in their documentation, they give like 99.99 with 16 nines. They write like that. So that's the amount of availability that they guarantee while providing their infrastructure. So we'll see how that guarantee comes and why that they are claiming such kind of numbers. Before that, let's talk a bit about kind of what types of compute, or I would say cloud, we have. So first is public cloud, like we see cloud on Google or maybe Azure, AWS. They are all hosted in public clouds. The best example would be Netflix, that we see every, like, millions are really using it very high. So that Netflix is completely hosted on AWS, and that has all those elastic stack. Like when the number of users increases, number of server also increases, and when the number decreases, server also decreases. So that is all hosted on public cloud. So what essentially public cloud is, that it is not handled by the organization which uh, who is using it. Public cloud, just like Azure or AWS, the infrastructure is handled by Amazon or maybe Microsoft in case of Azure. So those clouds are essentially public clouds, where all those infrastructure going into the data center, handling the softwares that's running all those data centers, the operating system that is running those data centers, all of them are handled by Amazon or Azure or any kind of service providers that we may see. Secondly, I'll come to hybrid, but first we'll talk about private cloud a bit. Private cloud is nothing but like you have your on premise systems, but nowadays cloud providers are coming with their own way of giving private clouds by virtual networks, so that all your clouds, all your components and resources deployed on the cloud will be within your own private network. So essentially, private means that it is not exposed to a public IP, it is not exposed to any other person beyond your organization. So that's where private cloud mostly is. But sometimes it's also that the data center that you are using, it is inside your own premise, and that is, you are handling the infrastructure, you are handling operating system. In hybrid scenario, where you have both, you have on-premise private clouds as well as you have the public cloud, where you use the infrastructure given by likes of Amazon or Microsoft. So it's kind of both, and you have, it's like a bridge of both. Generally, today, Gartner had predicted that most of the 75% of the data base that is lying, all the data that is lying would be on the cloud by 2024. So by that regard, we can understand, if at all this hybrid model is there today, there would be time where this on-premise system would be very less. I wouldn't say completely extinct, but there be a sufficient amount of use of public cloud and very few use of hybrid cloud. So companies are moving more towards public cloud, because the overheads and all the maximum advantages of having a cloud computing platforms comes with the public cloud infrastructure. So that's where companies are moving towards, and uh, we may see a very good boost in this particular space. um, like I already mentioned, for the public cloud, it's basically a third party server. It is also used and maintained, and all the security patches are ensured by the third party itself. So that's a public cloud. Private cloud is where you have your data center is in your own organization. It is exclusive for you, and people beyond your organization will not be able to access those because the network would not be open to public endpoints. So that's what private infrastructure is, or private cloud is. Even nowadays, Azure and like I mentioned, Alibaba and all those big cloud providers are giving private clouds using virtual networks. And that's what your private cloud is mostly. It's a very good example of understanding what private and public cloud is basically. In private cloud, like I mentioned, it's a very exclusive thing, which is if a particular company is using a having a private cloud, that means it's very exclusive to them, and all the data and all the computation would only be used by them rather than by any other company. But in case of public cloud, the infrastructure is basically at scale. They have a huge data center. They do huge investments, and entire maintenance and all those is taken care by them. So it at scale, there can be many companies using public clouds, like Netflix is using Amazon, but at the same time, AWS being used by thousands of companies across the globe. So that's a very good example of public cloud infrastructure. Like I mentioned about hybrid cloud, um, it's a combination of both. You have your private data center, as well as you have some part of it in the public cloud. How would you do that, and how do we decide that? Let's say in a scenario where we have a very a frequent use of data set in an IoT world. Let's say the sensor data is coming to from a healthcare sensor, which is tied up to a particular patient. So it needs to be computed and processed at the very place, because the lesser the data travels, and the lesser, the better the computation is nearer to the data where the data is generated. At that time we can get best out of it, because the time to compute it and to time to get the results out of it would be very low. So in case of healthcare, we generally have another paradigm which known as fog computing, where we have computing layers on our on-premise, but at the same time those computing layers are also connected to public cloud like Azure, or maybe AWS, or maybe Google. And that's how we basically ensure this kind of hybrid cloud technologies. And Google Cloud Platform and Azure by Microsoft, Alibaba Cloud, these are some of the cloud technologies and cloud service providers that we have, and across uh, you know across the globe. Like Alibaba is mostly in China, but at the same time Amazon, Azure and Google Cloud are well present. But at the moment AWS has the highest level of market share with 75% of it. But Azure is the next big computation, which we will look at in a couple of moments. And GCP also is not far behind. Many of the startups today are preferring to go to GCP because of a huge latest technology that's come. Like Kubernetes is one of the examples that was created by Google. Hadoop ecosystem, Spark, those are some of the technologies that was created by Google itself, which is today open sourced. So people definitely prefer to be in that raw zone, and prefer to be with people who have actually created those. So they have GCP for them. um, to broadly differentiate type of service offering that cloud provider give, as might you might have already heard of these terms: infrastructure as a service, platform as a service, software as a service, and serverless computing. um, what infrastructure as a service is, like I mentioned, you need to run a virtual machine. All those maintenance and all those infrastructure that is required for you to run that particular virtual machine is provided by the cloud computing or the cloud service provider. So that's what infrastructure as a service basically means. But platform as a service is more towards where it enables you, it gives you a common ground where you can develop softwares on top of that platform. Like Kubernetes is an example of platform as a service, on top of which you can deploy your applications at scale in a distributed manner. So which we will look at. I'll definitely give a brief overview of how many platform as a service we can see. Then we have the software as a service, like all those softwares that is running, like let's say we have this Azure Data Factory. That's a software used by data engineers to migrate data from one source to a destination. And Power BI, that you might have heard of, or maybe MATLAB on cloud, that those are all examples of software as a service. Serverless computing, like already I have mentioned, it's mostly about scaling out and scaling in depending on what kind of need it is. So those kind of service offering has come to the market recently, and it is hugely accepted by companies because that gives the capability of scale as well as cost cutting. So it's definitely the win-win situation for both, for cloud service providers as well as for the end consumers who are using those computing platforms. We will mostly in demo we will go through this Azure components, which is Databricks, Data Factory, Data Lake. Other two is SQL and Synapse Analytics, which is not which sorry, I guess there is some. Okay. So we will not go through Azure SQL and Synapse Analytics currently, but we'll look into Databricks, which is a distributed computing platform on Azure. Azure Data Factory, like I mentioned, it is most towards having pipelines to migrate data from one place to other. Then there is Azure Data Lake that we have to store data set when there is IoT data coming in from various sensors that need to be stored somewhere. So that's Data Lake, which gives 99.69 availability for us. This is a basic architecture. It's a very high level diagram so that it can be better understood, and some of the components which it better describes, as in how the cloud computing basically works. Like this layer that we see, backend and security, runtime, cloud storage, infrastructure, everything, that's a data center that we are looking at. And this internet is nothing but our connection that we regularly get, like maybe from your phone that you are using a GSM, or maybe you are connecting via Wi-Fi. So that's the internet connection that we are looking at here. And this client infrastructure is nothing but your laptop or maybe your mobile phone, via which you are accessing this services which is out there and hosted on the data center. So in this regard, the application service runtime clouds, these are mostly around the operating systems and the service software as a services that they provide. And some of the applications, like there are certain application which ensures log analytics, that ensures if there is a security breach, then you can directly get an alert on top of it. So some of the applications come out of the box with those cloud infrastructure. Apart from that management, you get a complete layer of which you can access, which you will also see, where you can get all the resources that you have created, like maybe SQL server or maybe a data lake that you have created. So everything would be there in front of you and just a click away from you. And from the security side, like Microsoft already has this compliance, and there is, just like we have ISI standards, there is standards for cloud computing and data encryption, data security as well. So they have got all those certificates that people can definitely check when before using it, while you are using any kind of sensitive data. Some of the clients, like healthcare sector, needs very specific security. Banking has very specific security needs, so they basically provide all of those with very standardized certificates and licenses. um, but to enable all these components, to enable this kind of client infrastructure where you can access those kind of huge scale computation just with your laptop, um, that requires some of the components. And to ensure that kind of security also, there are certain things that I thought we should take a look. And this is mostly from the network security side, since we are talking about IoT. And in IoT there would be lots and lots of networking stuff that we use. And But from the cloud computing perspective, we have this virtual network. This virtual network, like I mentioned about private cloud on top of your existing public infrastructure. But to ensure that privatism, or to ensure that kind of isolation from the rest of the infrastructure, public service providers or cloud service providers give you virtual networks, which ensures that your resources are not exposed to the outside world. Like I cannot basically query something from a database which has data of Amazon's employee, or maybe I cannot do a query of a Netflix customer database, because those are all hosted in their virtual networks, and that would not be visible to me. So that's what how cloud applications or cloud computing paradigm ensures isolation, gives a high level of security. Then there is network security groups. Maybe you are in, like in our institute, we might need a virtual network which only is very exclusive to us. But at the same time, there might be certain databases that should not be accessible to all of the people, all of the employees. Say a CEO of a company should have access to everything, but a person who is an engineer who is working for some project, he or she may not have access to all those details. So in that regard, this network security groups basically gives that kind of capability where you can select inbound and outbound networks. And also you can give a IP based security rule in case of firewall, where you can restrict a particular IP or particular device from accessing your resources. You can either use whitelisting, where you can only whitelist those, or only allow those networks which are whitelisted in your firewall, so you can use that. Secondly, auditory and log services. Let's say there is a security bridge in your organization, but how do organization know it, that there is a security bridge? They basically look at the log services, and those log services basically gives a very good amount of data about how the resources has been accessed, or what amount of SQL database we have used, or are we accessing any other components. So basically what we did on the cloud, those are all stored in Azure log services. And in case of any security breach or any kind of alerts that comes in, there is a service called Azure Monitor. And if there is a intrusion, or if there is a cyber attack, it directly alerts you, and gives you a control as in what actions you should take, or also suggests you with best practices. So these are some of the components that's really helpful from ensuring the security perspective when data is on cloud and on a public infrastructure. These are mostly the same thing that we talked about, and some of the examples of Azure of virtual networks is Azure VNet. These are basically the software names, and in AWS world it is it is called VPC, which is virtual private cloud. And some of the benefits, like we have already talked about: isolation, security, intrusion resistance, and control over your network. Like you can basically allow some people and disallow others. So there's a huge control that you get with those kind of virtual network environment. These are network security groups, like inbound and outbound traffic. Like let's say there's a resource, and there is some people who are accessing those resources. In that case, there is this, you can control what kind of inbound traffic that is coming, or who should be able to access this at the network level. So this is where network security groups comes in, and this is typically for an Azure environment. It can differ for others like AWS or Google. Firewall, it's very common thing that we get in our laptops as well. Like it doesn't allow all the IP addresses to access our resources. It only allows our own internal NIC cards. And but this kind of paradigm is really essential when we are talking about SQL databases or data lake, data warehouses. And each resources has its own firewall. That's the most important part. And it's quite believed that this is the last level of network security that we provide, and after that there is authentication and authorization that comes in. But in terms of network, firewall is the last thing, which restricts a particular IP. You can give a particular IP range. If your organization is using, let's say, a particular range of IPs, then you can provide it, and Azure would allow only those IP to access those resources. So there's a very good way of firewall, and having handling the same way that it was used on an on-premise setting as well. Essentially, when the data is on cloud, there are certain infrastructures or there are certain ways of storing it. First is SQL, that we all know or maybe we have heard of, like that's a relational database, and in that we generally store it in tables, and with rows and columns like normal Excel sheets, you can say, and those have various relations so that we can get optimized query when we read it back. So we have those. Azure SQL is an example of SQL database in Azure environment. Then we have data lake, just like we have file systems where we store our files, like let's say this PPT, I'm storing it on my laptop file system. In a very similar way, we store data, let's say a CSV file or an Excel sheet that you want to store on cloud, or maybe an image or video. So that's where data lakes comes in, and that's where ADLS Gen 2, what we call Azure Data Lake Services, and it's generation 2 that we have now. There is another new paradigm, completely new, which is lakehouse paradigm, which is a data lake, and a different computation and a different reporting. um, Essentially what this means is, in SQL what we have is you can directly query a SQL database because the server runs on top of it, the computation engine runs top of this database every time. But in lakehouse, that is not the case. We store the data in a very dumb file system, like let's say we have files stored in our laptop. Then we have to go there and open it, and then only we can see the file, right? So but there is no way that we can query that file in a particular format or in a particular structure. That's where this lakehouse comes in. We can store the files the way we want to, but at the same time we can give a structure, we can query the data, and also we can have very beautiful visualization on top of it so that we can find or see patterns on top of the data sets. We can see analytics on top of it, which we will look at in a couple of moments. Data warehouse is another big distributed set of data store, which stores relational data. Again, it's mostly from analytical side that we use Azure data synapse analytics or data warehouse, what it was called earlier. So in that case, mostly this Power BI, Tableau that we hear, which is very very fluent in the industry, those are being used with on top of these data warehouses. One of the real time use cases where we send sensor data, where we keep the sensor data in a particular place and then visualize those sensor data in near real time. Those are some of the use cases where we use this Power BI or maybe Tableau. And data warehouses, where we use that as a store, where we bring the data and store it and do analysis on top of it. Key value store, it's just another way of storing, where we have like a particular key. Let's say we have name is equal to Anish, so it's like name is a key and value is Anish. So that's way we how we store key value. We can store it in distributed way, and that's the advantage. Then there is queue, like let's say there is a streaming data that we get in IoT, obviously, so that's where we get a queue. Continuously data comes in, continuously data goes out. We get a very real time data streaming here. Blob store is similar to what we get on data lake, but here it's mostly we get huge amount of chunks of data but less optimized. NoSQL database is another enabling SQL query on top of key value store, those kind of paradigms. So won't go deep into it because it's not mostly used in case of analytics or in case of this IoT. But this is similar to that what we see in key value store. So it's like a distributed database where you store this all name is equal to Anish, or maybe place is equal to Bhubaneswar, and so on. So when we before moving on to our demo segment, where we will look at how the Azure looks like, and how we can deploy certain resources on cloud. What I thought, it's really important for us to look at some of the replications that we get. So to like I mentioned earlier, we get 99.99 percentage of availability of data. So how it's basically achieved? So first way is that it's LRS, which is locally redundant storage. So here what happens is, let's say there is a data center where you which you are using to create and store data. So what happens in normal LRS is that it creates a copy of your data set, and it keeps it across various stacks of computers. So let's say due to some kind of problem, one of the servers goes down, then you can still access the data because you are able to access it via other copies. You still have got two more copies to access. But the problem here is that what if there is a disaster, like there was a cyclone recently, and there might be data center hosted somewhere which got affected by some kind of natural disaster. So entire data center may go down, right? So in that case, we have this zone redundant storage, where in a particular zone we have multiple data centers, and this creates a more availability for us, like each copy of those data is available on multiple data centers. Like one of the data would be in Bhubaneswar, one of them might be in Kolkata, and another one might be in the east zone somewhere in maybe um, let's say in Chhattisgarh. So this can be distributed across geographical regions and across data centers. Then we have another way of replicating things, which we call as RAGRES, which is basically geo replication across. And we also have local LRS that we do on a particular data center, but at the same time we copy the same three data set across to a different data center, so as to have a very high availability of data. In case one data center goes down, we have another data center, and at the same time we have got three copies in case the data there is a problem in one of the racks or one of the servers here. We still get other two copies with us, which we can read and have make it available. And the third one is GZRES, where we get zone redundancy, we get geo replication, and also we get cloud local redundancy on the secondary region. So primary region and secondary region is nothing but let's say there is two regions in Azure cloud in India. Like one is central India, and another is southern India. So in central India, that is a particular region where that might be multiple data centers spread across multiple cities, or maybe spread across multiple with different land scenarios. But and when we have a secondary region, that means it is completely hosted in a different place. Like in central India, it might be in Maharashtra, your data might be there, and another replication of your data or copy of your data might be lying in some other data center which is in some other cities. So that ensures gives you a higher availability of data. And you have even though there is a disaster, you still get the data when you have very mission critical, like in case of ATM transactions. Let's say in case of ATM, those data sets, or when the amount is deducted from an account, it has to be reflected on all the data centers, right? In that case, and there might be a disaster in some kind of in a place where you are accessing that bank server, but that bank server is prone to some disaster. So there should be a way where your ATM machine is able to connect to a different server, and is able to give you the a transaction and give you the amount of data needed for that transaction. So that's how, by replication of servers, replication of data across servers and regions, we get this very high level of availability. I'll start with my demo on the Azure infrastructure. I'll share my screen. Probably I'm not sharing my Azure screen. Just give me a second. I hope it's available now. It's visible to you. Please, if anybody can confirm this, that would be great. Oh, okay. Okay, thank you. Um, so basically, when we log into our Azure portal, there is a different portals that we see across multiple paradigms or multiple companies that they give. But the first thing when you do, it's simply you log into their portal, and this is the home page that you get out of that portal. And this is where you basically create all the resources. Like I mentioned, you create your storage accounts, like it's here. You create your data bricks, which here as well. And you can see all the governance side of your stuff here. Like let's say you want to have maybe certain virtual machines, maybe some kind of databricks clusters which is running and helping you in driving some analytical needs. So these are basically the place which you land in when you first log into your Azure portal. um, I am much more comfortable with Azure portal, and I have worked across on-premise and private data centers as well. But what this kind of public data center brings is the ease of using it. I will quickly show you how you can create a data lake just in a couple of seconds. So you can simply go to the search resource and you can just type in storage accounts. You get recent searches here, like I had searched storage accounts earlier. But just to show you, I'll search it again. Just when you type in storage, you get a storage account, right? And in that storage account, you directly get what all storage accounts have been deployed in your Azure cloud. Like you can see what are the versions of it, what kind of storage account, whether it is. I am not going to go deep into the various types of storage accounts, but mostly you get all of that in a single go. Let's go ahead and create one. You just click on add. It's as simple as using one of your softwares, or maybe as simple as dragging and dropping stuff. So in here you select the subscription. We are on a free trial right now, so that's what the subscription is. I'm going to go ahead and give a resource group of demo. So I'll just quickly go and tell what resource group is. It is nothing but a logical separation. Let's say you are deploying multiple resources. You might deploy data lake, you might deploy virtual machines. So keeping it in a particular resource group, it gives you a logical separation. Let's say you directly go to this demo resource group, which we'll see, and within that demo resource group, you can quickly navigate what all stuff you have deployed within that resource group. So this gives us a very good way of logically separating various resources that has been deployed, because in a company there might be tons and like many resources deployed on the cloud. So and many teams also using the same cloud. So this kind of resource groups helps in segregating those resources and having a very good way of identifying and also having a good logical separation. Then we go and give a storage account name. Let's say we give the name as demo FTP silicon here. You may see here that you get this error. Because why I type this error, because I wanted to show that why this error comes basically. Just give me a sec. I uh, I guess font is small, but I'm trying to share the entire screen. I hope. Please let me know if it's very small. I'll try to expand it wherever I am explaining. So, what I was trying to say is, when you create a storage account name, this storage account is basically also gets created with a particular URL, of which, like, let's say we have this URL of portal.azure.com. Very similarly, we have a URL for storage accounts, which is like the storage account name .dfs.azure and so on. So but a URL cannot have this special characters like this dash or maybe a dot or maybe underscore. So as soon as I have deleted all those dash, right now the error is gone. So that's the reason why we get this error, because ultimately it would go ahead and become a URL which you would access. Here it's a very important place, region. So this is a particular geographic region where you want to deploy. Like I mentioned, we have South India, West India, and mostly recommended is Central India because it's quite mature data center out there. So I'll just go ahead and select Central India, which is where my this particular storage account would be deployed, and I can start using it. Here is the redundancy that we just looked at, like what kind of redundancy we can get. Do you want to get LRS, like only 3 copies at particular local storage, or do you want to have geo redundancy where it is copied across multiple geographies? So we can select it, but I'll keep it as LRS, just because it's a demo and I don't want to replicate it across. Then I can go to advanced and see what kind of features I want to enable. One first things is enable secure transfer. So when there is a basically transfer of data from one data center to other, or maybe one resource to other, there might be data leakage, and somebody might be have intruded the network and might get the data out of it. So while you enable the secure transfer, what it does is it gets the data encrypted, and when the data is encrypted, if at all there is an intrusion via network and the intruder gets a chance to get the data, it would get encrypted data, and that would be not of any use. So that's what enable secure transfer is. Infrastructure encryption, you can enable or disable it. Infrastructure encryption is nothing but encrypting all the data that you have and on the cloud at rest. Why we call at rest is when it is just not doing anything and it's just stored. Like let's say we are storing something in our laptop, a movie or maybe a photograph. That means it's stored at rest. It's not being used right now. So when you enable this infrastructure encryption, whenever the data is not used, it would be encrypted, but there is an overhead of computation and cost. So you have to depending on type of data you are handling, whether you are handling sensitive data, whether it's needed for encryption, based on data governance need, you can enable or disable this. Blob public access, this is one of the very important one. Right now I have enabled this one. But what this means is, when you have this public access, that means anybody out there on the internet can access, who has this access keys, who we will see what access keys are and what the passwords and authentication are. And some of the um, here you can see that we have enabled account key access. You can also disable this, and you can simply use your Microsoft account like Outlook email ID for all those access. But it's very good to have this access key because you need other infrastructure services, like let's say data lake is there, but to access that data lake there might be Power BI which is trying to read data from your data lake. So or maybe any other application, maybe you are running a website which is trying to download some photograph from your data lake. So that's why you need to have this access key, so that that access key can be used across via those in those applications to access all those files and images, everything. um, then this is the data lake storage and to enable hierarchical namespace. This is one of the key things when we are dealing with big data. When we enable this, that means we are basically enabling hierarchical namespace where we have this folder structure. In case of normal storage account, what happens is nothing is like, there is no concept of folder or directories. Underneath, you can, on the top you may see it because Azure guys designed the UI such a way, but underneath at a storage level it's just flat files are lying across. So which definitely it's not very efficient way when you are reading something. Like let's say you are handling a lot of files, and you are tasked to get roll number 5 of triple A or triple B or any of the sections. So in that case, if you have your file stored in a particular directory structure, like triple E is stored differently, EC is stored differently, and then you have a triple A and B stored differently, so you can directly go to those folders and directly search it, rather than driving, so looking at all the files across. So that's where this namespace comes from. So, I mean, it gives a directory structure on top of normal storage file system. I'll just enable this as of now. Azure files and tables and queues, these are other kinds of file system which I would not go as of now. Networking, again, we will have a public endpoint because having private endpoint means we have to deploy a private network, and that would go beyond this session. So I would stay with public endpoint as of now. Microsoft network routing, that means you will use Microsoft's infrastructure, network infrastructure, to route traffic from various Azure resources. And I mean, that's perfectly fine because that ensures our good way of data protection. And these are some kind of other data protections that we get on top of the storage accounts. But since we have enabled Azure Data Lake hierarchical namespace, we will not be able to see this all. Tags, let's say you have created some of the resource, you want to tag it, and when you tag it, essentially what it means, you can search it much more efficiently. Maybe you are working for a project which is on development of some application, so you can tag it, tag the name as the application and give a value of the application name here, so you can search easily. But you can keep it blank as well. Finally, you go for a validation. So you can see here, cloud automatically runs a validation of the configurations that you have passed, whether it is right or wrong. And when the validation passed, you get this green signal of validation passed that you can see here. And once this validation is passed, you can that simply go ahead and click on create. What it would do essentially is that it would submit the deployment file. We have this very good ARM templates that comes with Azure, so it uses those and deploy our data lake. So you have seen in couple of seconds and couple of clicks, we have deployed a scalable Azure data lake which can scale out to petabyte scale, which can power likes of Amazon or maybe likes of Google. So this is that easy to, basically cloud computing brings things that easily deployable, at that easy to use, it's that easy to deploy. Once that is deployed, you can see here, it would come here since this deployment is in progress. Now it is deployed, so you can see here we have got a green signal here, and you can simply go to this uh, a newly created Azure data lake, and you can see what all details of that. Location, you see Central India. Subscription, we have what kind of account type, whether it is, what kind of replication we have set. This is the TLS that I mentioned while you are transferring data, what kind of network access it has. You get everything right here. And just a click away, you get the access keys. Like I mentioned, by using those keys, you can just take these keys and use it in your application to connect to this ADLS account. And that's a very easy way of handling a petabyte scale data set, and where you are dealing with every day with a new demand, every day with higher scalability demands. Similarly, you can create other resources as well. I have created certain other resources, like I have created this data factory resource, and we'll go and look at this data factory resource in a couple of moments. Then there is this data breaks as well that I have also created to save time. And I'll just launch this workspace. So when you launch this, it goes ahead and launch that particular service for you, and you directly get access to a large scale cluster just at a point of click. While it is launched, you get the first home page here. You get all those whatever you want to do, and like I mentioned here, you get various workspaces, you get various notebooks. So what notebooks and workspaces are is basically set of codes that you see here. So there's a set of codes that we write on a database. So this is a sample code that I have uploaded for us to go through. What we are doing is nothing much. We are reading some of the data from this data.gocsv file, and we are then querying that data, which is display data. we have done some kind of, we just took a look at take 10. That means we are just looking at some top level data set and we are trying to display it like here. And the best part is using the same data we have in the same notebook itself, we are able to plot the data set of the state code and entire thing. So you can see what are the number of sales price, median sales price of each state out here on the map. So whenever we give to, let's say, a analytical report to a CEO or a manager, we can directly use this kind of a notebook, and we can see. And on a IoT sensor basis, let's say we have sensor deployed across multiple geographies, we can have this kind of visualization to get those data in this more enhanced visualized manner. We get set of other uh, you know visualization as well on top of it. But what is worth mentioning here is this query that we write. So these are the tasks that as a data engineers day-to-day life goes into. So they generally are responsible for writing these queries, this analytical queries. And to write this analytical queries, there's a huge studies that goes into exploratory data analysis, and then there is schema analysis, data modeling, and lots of other stuff. So before that, after that we do all this kind of analytics on top of it. This data can be anything. Right now it's a sales data, but this can be a IoT sensor data as well, where we have let's say based on some region we can get what is the percentage of humidity across the various sensors that we have. So we can get pie charts, we can get this kind of a geographical visualization. Some other visualization which might not be very appropriate for this audience, but I mean good or useful for this audience, but definitely this is something that we are capable of using Databricks. Then there are tons of others actually, which I created recently from one of the tasks. So you get this this kind of a service. So this is basically a software or platform as a service that we call. We have got this platform, and on top of this platform we are creating this kind of application using writing codes on top of good amount of computation, good amount of infrastructure, and so on. Next, I wanted to show some bit of data factory. How you launch this data factory is when you are on home, you simply go to this data factory and you can see what all data factories has been created for you. You can go ahead and just click on author and monitor. So once you click it, you basically reach to this home page. Um, just authenticate it. So it authenticates with your Microsoft Outlook account, and we get to this home page, which gives us basically brief what exactly it does, like copy data, pipeline, everything. You can go ahead and author some of the pipelines, like I had done, authored some one or two demo pipelines for us to look at. This pipeline has multiple activities like copy and transformation. There are multiple functions. You can invoke data breaks that we just saw a couple of moments ago, like this particular notebook. And here we see machine learning as well. So let's say there is a data set coming in from multiple sensors. We can have a pipeline here, like this copy data pipeline, which is copying data from a particular place. And then you can have this machine learning batch processing or machine learning training algorithms right here at the end. And how you do it is by dragging and dropping it. It's as simple as that. And you just connect it just to give a sequence as in which activity and is to be performed after what. So you can give that. You can then have this machine learning studio where you select your machine learning code, and then you can execute it right from here. Apart from that, we have various one storage account that I had already set for this particular session. And in there we have this one particular file that we will use to copy from one place to other, and that essentially is a uh, you know okay, copy activity of a pipeline activity, which we call a data migration activity as well. And in that, in a real world scenario, that data migration activity may happen from on-premise SQL database to cloud or anything else. So here we have a CSV file, and you can see here what is our container name. Container is nothing like a folder. So when we go to a storage account or a data lake, we get this kind of folder structure. So I want to copy this as your demo product CSV into this particular folder. I already have one, so I'll go ahead and delete that first. You can simply go ahead and delete it just like you delete in your normal file or maybe a laptop. We'll go to the pipeline now. I'll show you the pipeline. I'll just delete this activity. This is a copy data activity. Like from the mention of the words, you can know what it does. It basically copies the data. I have given a reference to the source data set. So source data set is like, we first have to connect to the data that is here, which is in the first container, which is Azure demo. And then we need to, by connecting that, as you can see, the file path is Azure demo, and the file name is product.csv. And I want to copy that into Azure demo sync folder, and that's what the file path I have given here. And that's what I have also put in here. So source is the first delimited text where I had that first file, and on the sync side, that's the second delimited text which I defined as the Azure demo sync. It's it might look a bit complicated at first, but trust me, when you work for once also, you get a very good understanding of it. And once you create this, like you just saw, I just created it within 1 minute or so in front of you. The pipeline is ready to start copying at scale. You can go ahead and just trigger that pipeline using this play button that I just triggered. And once you start that, you will get this particular status file, and you can see that the copy has been succeeded with the default integration runtime, which is hosted in central India, because this data factory is hosted in central India. So we will go back to our storage account and go back to the sync from which we had deleted the data, and we can see that we get that particular file just in a couple of clicks. So all in all, the data factory, the likes of data factory, the services likes of Databricks or any other platforms like we saw, it all makes lives very easy. The deployment of resources that's enabling infrastructure at scale at the levels of where Amazon or Flipkart or maybe Alibaba are operating at. And the best part is, if you are a startup and you want to start opening and create an application, you just get this kind of an infrastructure which was not available earlier to founders. So having this kind of infrastructure just a click away enables researchers across industries. People are doing humongous amount of research using this cloud computing platform because they get this kind of infrastructure just a click away, and all those service overheads are, they need not to worry, they just need to get easily using those cloud computing environments and infrastructure. um, that's what I wanted to share on the demo side of Azure. And like I say every time, it's just a somebody else's computer. So whenever we are using any kind of public cloud or anything, we should make sure that all the compliance of that cloud service provider is met, and all the compliance are also met. There is a huge in case of insurance companies, in case of banking, there is huge questionnaire that we get from those clients that we have to fill in, because we need to certify them that we are certified, we are able to process, we have all those compliance met. So there are huge amount of work and overheads, and I guess cloud computing is the best way to take away those overheads and focus on your core work, core application, maybe your research, maybe any startup idea that you are having. With that, I would like to end my session here. I would love to take any questions. Um, Please. So this is a very good question. How we can relate IoT to cloud computing, and where we will use it for IoT transactions. So in case of cloud computing, I will quickly show one of the services that we get for specifically for IoT. Um, just a couple of minutes. I got another question as well, I guess. If somebody wants to unmute yourself and please want to ask me, please go ahead, because reading these questions would take time. If that's fine, please.
Unless I'm just doing it for you. Okay.
Yeah,
No
sure,
problem.
please. Now it is possible for apps to malfunction or for IT infrastructure to collapse.
So
How can
good
we?
afternoon.
Yeah. Hi.
So myself Satyanarayana.
Yeah. Hi. Hi, Satya.
Yeah, hi. In free trial version in Azure, how many
Yeah.
virtual machines we can connect at a time?
So it depends on like how many cores you are operating at. Let's say you are deploying your virtual machines in USA. It has its own limitation of 4 cores, I believe. I don't exactly remember the names, but depending on how many cores you are using and how many permissions you have for your subscription in that particular region, you can create number of virtual machines.
Okay.
It can vary. I mean, large cloud clients, like I was working with one of the biggest insurance companies in UK. They had tons and millions of I mean thousands of virtual machines running in a particular region, so it all depends on what quota you have.
Okay. Suppose when we created one virtual machine with all infrastructure,
Hmm.
okay.
Hmm.
So can we change after the creation?
Yeah, absolutely.
Yeah.
Absolutely. So that's the best part of amazing, very good question. So that's the best part of cloud computing. I'll quickly show this virtual machine to you. I haven't created anything, but I'll just quickly add one in front of you. So let's say you want to create a virtual machine. You can directly just use this particular resource group demo and just name their virtual machine. Let's say I give a demo virtual machine, demo VM, and I can create in any of the regions. Let's say I created on central India. But once you create it, there is always a need. Let's say tomorrow your memory needs increases, there is a graphical need that you might want to run some machine learning models in your virtual machine. So you can change any day, anytime. Some of the things that you may not be able to change, like I believe you cannot change operating system image. We cannot change one sec. I You cannot change your resource group, you cannot change your network settings. But in terms of your configuration, like you want to have more memory, you want to add some disks, you want to add some more cores onto your virtual machine, you can do that. So that's completely flexible. I hope I could answer your question. Okay, I guess I got a couple of them on the chats. So I have got to go. The Internet of Things is a such a vast and diverse network. It is possible for apps to malfunction or for the IoT infrastructure to collapse. How we can ensure privacy? Companies are now revamping their IoT strategies by creating updated Kubernetes-based public cloud deployments, which means big additional investment before rolling out IoT on a global scale. Do you have alternative ideas? This is a very good question. And it's not that everybody is deploying everything onto Kubernetes, and specifically from the IoT side, people are migrating more towards a time series databases. They may deploy it on Kubernetes, but still deployment of databases on Kubernetes is not fully studied, even though it's not if at all not studied, if it's not recommended for a production use. Some of the databases or some data stores are still used, like we have this vMsphere link where we store data across multiple data centers using their storage classes of Kubernetes. And the cost, you there was one question around cost. Having a Kubernetes cluster itself is very kind of costly for starting up. starting it up. But to run, if you have a good amount of requirement, let's say you have a requirement of 100 sensors or 200 sensors being processed via your Kubernetes services, then I guess that's one of the best ways to have it processed. But what happens on a public Kubernetes service is that you essentially pay for the virtual machine, and on top of that you also pay for Kubernetes. So that doesn't make sense on a public cloud environment, for me at least. What are the alternatives to that? As there are tons of alternatives, one of which is very native to any kind of cloud. Azure has Azure Functions, which is very elastically scalable, very similar to that of your Kubernetes. It has its own way of dealing with processes. It has its own way of triggering processes. So we have Azure Functions in Azure. Then there is AWS Elastic Stack that I mentioned. If you want to deploy a certain web server which is powering your IoT, needs with complex network applications, so in there you can use those kind of alternatives in place of Kubernetes if you want to. But if you are targeting on an open source and cloud agnostic way of deploying stuff, I believe Kubernetes is one of the best way. There are other orchestration engines as well out there in the market, but the huge amount of community services and the community deployments coming to Kubernetes is quite tremendous. Recently, SQL Server also have moved one of their SQL Server big data cluster. That's what they call it. So there's good amount of chances that you can use alternatives, or you can simply use Kubernetes. uh, any other question that I can I'll just look at the chat. You can so when you say virtual sensor networks, I believe so there's a question here: can we create virtual sensor network on Azure? So when we say a virtual sensor network, but it wouldn't make sense at all, because when we are deploying sensor, it has to be on the field, right? And all those sensors, I believe, would be should be interacting within their own sensor parties, like let's say in a Zigbee environment, or maybe in a Wi-Fi lane environment, or a LoRaWAN environment. The sensors talk to each other and they talk to a kind of centralized server. But in that centralized server, you can definitely connect the centralized server which has already collected all the data from your sensor network, and then you can create a virtual network where you can send that sensor networks on a very classified way onto your Azure, if I understood it right. Yeah. um, any other questions that I can help with? Sorry, I guess I have certain other questions. How IoT and blockchain can be related to cloud? That's a very good question. So IoT and blockchain uh, cannot be related. I won't say it's very related at all, because IoT is mostly about the philosophy of IoT is making things able to talk, so that the monitoring stuff that earlier people had to do by going to fields, that has to, that stops. So that's what the philosophy was with when IoT came in. But blockchain is completely different. It's a distributed networking computing paradigm where we have various mining computation power coming from various environments, and from there you can basically use one particular network. Like there is Ethereum network, there is Bitcoin network that you might have heard of, and there are other blockchain technologies as well. People are using today blockchain to transfer medical images, to transfer health records and electronic medical records across, because that ensures encryption. At the same time, there is no central person who verifies it. It's a very democratic way of verifying it. That's the reason why many of the hardcore coders and people who do hardcore development stuff, they prefer to do things in Bitcoin and transaction in Bitcoin, because it's a very democratic way of using a currency. Or distributed computing is the best way of explain what exactly is blockchain. Whether LoRaWAN can be implemented in Xilinx platform to transfer certain signals. So LoRaWAN with Xilinx platform, I'm not very sure. I haven't worked on Xilinx platform, sorry, but I have worked on a bit of LoRaWAN. I believe there are certain libraries that is coming with various other platforms, and there are tons of them. It's not definitely that you have to only use a particular platform. If you want to use others, you can definitely, but I'm not very sure about Xilinx platform, sorry. uh, on the top, NRD defines a secure wireless network security credential and exposes the entire network. How can we? So there were a couple of questions on the top which I have skipped. Sorry for that. Um, one of we have 1 2 minutes, but I'll try to cover it as much as I can. um, Most connected devices today are limited computational power and are incomplete with robust protection mechanism. How can we mitigate? So, very good question is around most of the connected devices are definitely power constrained and computationally constrained. That's widely because we want to have large amount of sensors deployed in a particular site. But the way what I think to mitigate is to use fog computation, where we can have a fog layer in between your cloud layer and that of your end sensors. By fog computing, you can definitely have a computation layer very near to your sensors, and you can basically transfer your sensor data there, and you can process it in an efficient way. So that's another way you can use for robust protection. You can use encryption, but again, encryption has come to network constrained devices as well, with very good algorithms, and which is specifically designed to run unconstrained devices. So by that, you can ensure your data protection via encryption. Another thing, as you mentioned about, there is one question about I believe authentication issue. When IoT device that fails to secure wireless network security credential, then exposes the entire network. Uh, so in case of networks credentials, and when we say exposing the entire network, that means we have certainly some of the loopholes or some of the circuits that has certain exposition to a endpoint which should not be. Ideally, all the endpoints that exposed maybe in an IoT device, or maybe in your laptop or any other organization, you might have APIs which is accepting IoT sensors data. So that all has to be deployed in a virtual network, and virtual network is where you can basically secure all your network transaction. And there is no way that outside network can, I mean, somebody who is outside your virtual network or private network is able to come into your network. But there is another way. By using VPN services also, you can ensure some kind of encryption on top of your traffics that you send to I mean, from sensors, or from your fog computing layer onto cloud computing platforms. I hope I could answer those. Is there any other questions that I can help with, or we can call it a day there?
Unless there are a few questions like, can we create a virtual sensor network using MS Azure?
So virtual sensor network, like already mentioned. So when we talk about Azure, or when we talk about any cloud computing, it essentially is a different data center altogether, or different computer altogether. If we see, let's say we group a pile of laptops tomorrow, and we tell that we will give a infrastructure to people, so we can take those laptops and put it at a place, and that would have its own network, that would have its own computation, own electricity and everything. But when you talk about sensors, that means you are deploying a particular computation, a particular absorbent or device in a different place altogether. And the only way where you can connect is via some medium. Maybe you are using a 4G GSM, maybe you are using a 5G network, or maybe you are using LoRaWAN. But in case of Azure, since it is hosted on a public infrastructure, you need to have internet to connect to it. So, and delivering internet to each and every nodes in a IoT endpoint scenario, or in an IoT scenario, it wouldn't make sense, because the GSMs essentially takes up a lot of energy, and it has its own limitation. But maybe with 5G, because with 5G, some of the protocols that 5G is using is highly energy efficient. But unless and until Azure is not coming to the to the fog layer, or maybe to the ground level where you have actually deployed your sensors, there may not be a chance of virtual sensors network on Azure at least.
One more question is there, whether a LoRaWAN
Yeah.
can be implemented in Xilinx platform to transfer certain signal.
Yeah, so like I answered this, sir. So LoRaWAN is a protocol. There are lots and lots of people who are giving or servicing devices which is enabling this protocol. I'm not very well versed with Xilinx platform. I had worked on LoRa, but I'm not very sure which platform was that. But there are tons of APIs which you can use it, which comes with LoRa, and definitely. So that's what I would say.
I think the last question, sir, which can be the research topic for IoT and cloud computing.
So to answer this question, this would be a very very huge topic. To do very specific research on cloud computing, I would say it would be mostly on the side of orchestration, where serverless computing is coming into picture. Orchestration is nothing but how various applications that you are deploying on a particular infrastructure is talking to each other, whether if there is some kind of breakage in your system, how it is able to auto recover, and so on and so forth. So orchestration is a very good place to research. Another good place to topic to research on IoT is like it's already mentioned, security in power constrained devices. And if at all you want to connect both of it, so there can be huge amount of research in the network that is going between cloud computing and IoT. But if at all you want to expand this research topic, I would suggest fog computing is also a very good place, or very good area that you can focus while you are connecting these two paradigms of IoT and cloud computing.
Thank you, Anis. I think there are no more questions. So over to Anupana.
Thank you so much, Anis. You presented very nicely about cloud computing, its architecture, storage, types, advantages, and different examples of its application in different software platforms. Also, you have nicely demonstrated the Azure platform. On behalf of our department and the entire FDP team, I thank you once again for joining us.
Thank you, ma'am. Thank you for having me and giving me this opportunity, actually. So I hope this session was really very, I hope this was informative for everyone. At the same time, thank you for inviting me and giving me this opportunity to interact with Silicon once again. So being an alumni, it's always really exciting to be, with people with whom I have spent my amazing 4 years. So thank you so much.
Thank you, Anis. Thank you.
Next, we will move forward for our lunch break. We will resume back at 2 o'clock. Thank you all. Have a great day.
Just a minute, ma'am. Ma'am, there is a certain change in our schedule, program schedule.
Yes.
That is due to some problem with our next speaker, MS Nidhi. The program of today is being changed a little bit. So in place of MS Nidhi, our speaker, Dr. Sanjay Kumar, will deliver his talk at 2 p.m. sharp today. And MS Nidhi will deliver her talk tomorrow at 9 a.m. morning. So thank you everyone and we need your kind cooperation. Thank you. I request Pritam, please.
Hello, Soumya. Good afternoon. Annapurna ma'am. Hello, Soumya. Good afternoon.
Good afternoon,
Hello,
sir.
Sanjay sir. Good afternoon. Sanjay sir, good afternoon. Soumya?
Yes, ma'am. I'm just checking my sir's phone is not connected. Sir's microphone is not connected.
Yeah, I think some problem is there. He must not have connected headphone properly.
Okay, ma'am. Let me call Sanjay sir.
Yes, Soumya, please call and discuss with him what's the problem.
There is some problem with Sanjay sir with his system, so he needs to restart. So it will take some time.
Okay, fine. We'll wait.
Sanjay sir, will you please try to unmute your microphone?
Yes.
Yes, sir. It's working.
Good afternoon, Sanjay sir.
Good afternoon, sir. We will start the session with a couple of minutes.
Sanjay sir, good afternoon. I think he is mute.
Yes, ma'am.
Okay, fine. Let him arrange.
Hello, good afternoon.
Good afternoon.
Vandana ji, good afternoon.
Yes, good afternoon, sir. And thanks a lot for, with short notice you are here. Thank you.
His notice is not short because you have already informed me long back.
Yeah, but for today's session.
Yes. No problem. Only thing, last minute tuning could not be done. That's it. Otherwise, there is no problem at all.
Yeah, thank you. Soumya sir?
Ma'am.
I think we should start.
Ma'am, just only 50 participants are there, so such talk is necessary.
Okay, so let's wait.
Yes, ma'am.
Okay.
Am I audible?
Yes, sir, you are audible.
Okay. Because sometimes my microphone is not getting connected with the computer, so I have to restart. But if I'm audible, there is no problem. It's fine.
You are audible now, sir. Clearly audible. No problem.
Workshop will become brand.
Ma'am, I think we should start now. Sir, shall we start now? Sanjay sir.
Yeah, from my side, there is no problem. You can start at any moment, whichever you like.
Okay, sir. I request Annapurna ma'am, please take over the charge and continue the session. I request Annapurna ma'am. Thank you.
A very good afternoon to one and all present over here. Let us start our post-lunch session. In the first two sessions, we have learned much about the 5G and 6G communication with its application using artificial intelligence and machine learning, and IoT in public cloud, which were highly appreciated by you all. In the third session of day 4, we are going to receive some more insights to IoT and 5G technology. Let us welcome our third speaker of today, Dr. Sanjay Kumar. I take the privilege to introduce him. Dr. Sanjay Kumar received Doctor of Philosophy program in wireless communication from Aalborg University, Denmark in 2009. He is presently working as an associate professor in the Department of Electronics and Communication Engineering at Birla Institute of Technology, Meshra, Ranchi. He has above 34 years of teaching and research and work experience in the field of wireless communication. He has conducted several training programs on self-development and teaching. He has been closely associated with organization and reviewing process for several national and international conferences and workshops. His research interests lie in the field of wireless communication technology with focus on wireless signal propagation, fading, channel impairment, removal techniques, flexible spectrum uses, cognitive radio networks, and technologies for 5G and beyond. Now, I would like to invite Sir to deliver his talk on the topic 5G and beyond communication system. Sir, please.
Very good afternoon to everybody. And I will present with the help of the slides I have made for this particular occasion. So I'm going to show the slides, and with the help of the slides, I will start my presentation. Is it visible to you?
Yes, sir. Yes, sir.
Hello? Okay.
Yes, sir, it's visible.
Okay, now I would like to say, yes, as I have learned in the introduction, I am not the first person who is going to speak about 5G and beyond communication system. But definitely, if two people are talking on the same topic, it is not necessary that both of them are going to deliver exactly the same thing. What matters is the perspective. I have my own perspective to discuss what is 5G and what are the various possibilities for IoT to work for 5G and what we can really think about the next beyond 5G communication system. This is what is in my mind and I'm going to discuss. Okay, let me tell you before starting this, let me tell you, I do not have much knowledge and any expertise related to the IoT, but I have some understanding related to the communication, and I understand, and all of us understand, when you use IoT, it is going to work on networks. It is going to use communication system very, very heavily. So unless we understand the communication part, the knowledge of IoT will not be complete. So what is my role here in this presentation is I'm going to focus more on communication, but definitely this will be your responsibility to listen to my concept, listen to my discussion, and try to relate those with IoT. Although time and again, I will be referring the word IoT, but it is your more responsibility on your side that you should be able to relate with IoT, the 5G and beyond communication system, what I'm going to make the presentation now. Okay, so the whole presentation, you will find the sequence goes like this. I would talk about the wireless networks first. And why wireless networks? Maybe in coming 1 or 2 slides, it will be very clear why we want to talk about the wireless networks. After we complete our discussion, maybe in 4 or 5 minutes, after we complete our discussion related to wireless networks, we would like to talk about 5G. What is 5G? And during this discussion, we will find that 5G has got a very intimate relation with the IoT. IoT is one of a very, very important component that will help realize 5G. We'll talk about the various uses scenario that is envisioned for 5G. And we will see at this particular point, if we have these many uses, then to realize those, we need to think very, very deeply how the implementation could be possible, what enhancement in technology will be required, or what newer technology will be required. So this, we will be discussing about the various technologies that will support 5G implementation. See, as the topic says, we are going to talk about 5G and beyond. Okay, but your FDP is related to IoT in 5G. So basically this restricts me from going beyond 5G, but I would like to say, because this is very important aspect, once we are working on IoT today, the job is not stopping in a year or two. See, we need to have something in mind that is going to come in future, maybe not very, very far, maybe 5 years, 6 years, 7 years from now. So basically, after we complete the 5G technologies, we are going to discuss certain aspects that is taking shape today. And this is going to evolve tomorrow. And we can call this the emerging trends we are able to envision. And we will talk about the upcoming generation. Definitely, it means when we talk about 5G beyond, that means we are thinking about 6G. So we will have some introduction related to the next generation also. So let us understand why we really want to talk about the wireless networks. See, some projections related to IoT, we need to know. We are aware. Say you have much information related to IoT and you have much information related to the amount of devices are going to be IoT enabled. Okay, but some of the projections which I would like to cite here, one is from Cisco Annual Internet Report, and they say by 2023, nearly 2/3 of the global population will have internet access, and this is almost 5.3 billion population. And surprisingly, this will be many more folds. The networked devices will be many more fold compared to the total amount of the population, total number of the population. So this will be 29.3 billion network devices. See, this is what is the projection of the Cisco Annual Internet Report. But we need to understand, if they have made this projection, will it be perfectly all right? See, it will not be perfectly all right. All of us understand this is a kind of an estimation. This is a kind of a projection. And when you project something for the future, it gives you direction to put your energy to work for that. See, they say this will be the huge amount of the huge number of the network connected devices are going to exist tomorrow. And for this, we have to make it possible. See, another projection I would like to cite from Ericsson. They have said that by 2025, 5 billion IoT devices connected to the cellular network. See, at first go, you will find 2023, this is 29.3, and 2025, this is only 5. even 2 years later, how it could be. But let us not focus on these numbers. Let us focus what it is really talking about. See, networked devices will be 29.3 billion by 2023, but the devices, IoT devices connected on the cellular network will be 5 billion. So you understand, networked does not mean that all of them are going to be connected with the help of the cellular networks. There will be one small part of the total network devices that will be connected to the cellular network. And cellular network means we are going to discuss related to this today as a part of 5G and beyond communication system. But how this we will discuss, but why we are going to discuss this, maybe it will unfold in 1 or 2 more slides. Okay, but what is the trend today? The trend is we are leading towards a hyper-connected world. See, one of the projection I would like to cite here, I have not shown in the slide. In 2017, Wireless World Research Forum, they have made one projection. Not by 2017, before 2017, that by 2017, per individual in the world, there will be 1,000 connected devices. That was the projection. Okay. See, that projection will be right, that is right or wrong. See, this is really not a point of concern for us. The point of concern is the indication it is going to give. It is going to give us an indication that, see, we are leading towards hyper-connected world. Lot many devices surrounding us are going to get connected, and many of the devices are going to work without our intervention. Okay, so these are some of the projections. This slide only has one meaning, that we want to understand the significance in near future about the IoT. And working in the direction of IoT is going to help us to create a good future for us, because we will be working in research, we will be working in development of IoT, and at the same time in the technological domain. So let us understand after this, all of us know IoT. But I would like to cite some of my understanding related to IoT is, definitely this helps people to be more connected to the world around them and do more meaningful higher level works. See, what does it mean? All of us know. See, if you are involved in smaller things, those can be taken by machines, then you should not really waste your time and energy on those things. You must go for higher level things. In this, IoT is going to help us. This is one aspect of IoT. Another thing we need to know, we know IoT is making the fabric of the world around us smarter and more responsive. We understand the meaning of the term smarter. See, when you take the basic definition of the term smart, we understand a device, not necessarily device, anything. You can call a person smart. What does it really mean? It means that the person is able to sense the environment, able to understand the surroundings, and based on that understanding is able to make the proper response. When a device has this ability, if the device is able to understand the surrounding, if the device is able to assess the surrounding, and according to the need, according to the surrounding, if it is going to respond in a proper manner, that means we can call this a device. So we understand it is making the fabric of the world around us smarter and more responsive. Okay. See, IoT extends the power of the internet beyond computers and smartphones to a whole range of things. See, whole range of things means things will be enabled by certain things, and this we will discuss maybe the next slide. Okay, things means not everything, but most of the things which are usable by us, and those will be enabled to communicate. See, helps realize ambient intelligence. See, we understand the meaning of the term ambient intelligence. It simply means that the fusion between the digital and the physical world. So we live in a physical world. We take the help of the digital world to assist, to express, to represent. So basically, when there is a merger, fusion between these two, that atmosphere, that ambience, that circumstances is known as the ambient intelligence. And it is the IoT that is going to make it possible. Now, let us understand, when you talk about the IoT, you will know what IoT really is, how it is really coming from, where it is coming from. So we need to understand IoT brings together technologies in the domains of a minimum two things we need to understand. One is the communication technology, and one is the, you can say, the device development technology or the sensor development technology, you can say. So basically, when you talk about the IoT, and if you want to fragment in two parts, then one part you will say the communication part that makes it working, and another part is the fabrication, the development. So basically these two. Now you can understand when I'm going to talk about 5G and beyond, it means that I'm going to focus on communication part. And when I'm going to focus on communication part, this is our responsibility that we need to understand, focusing on communication, how it is really going to relate to the IoT devices and how it is really going to do for IoT devices. Okay, so our part is on communication. Let us understand, when you look at the overall, the major components that constitute IoT, see, there are devices, embedded devices, sensors. Then we have the connectivity. One device should be able to talk to another device. Individuals should be able to talk to device. So for this, we require the connectivity. Then the sensing information can be collected and the data processing will be taking place. And finally, users interface is going to support individuals whenever it is really required to access the information. So these are the basic components we can understand. But let us know, where is my responsibility today? My responsibility is connectivity. When you talk of the communication, communication creates connectivity. So my focus is on connectivity. See, IoT uses networks to communicate between devices. We are aware, we know very well, but the networks, communication, networks, and let us understand, see, it is not necessary that IoT will use only and only the wireless networks. It can use the wired network also to some operations, to some extent. Okay, but major part, the way the IoT is developing, we will be able to see, we are able to see that the major part of the communication is coming from the wireless networks, is being supported by the wireless networks. But in order to realize this, I'm going to show you the next slide. Okay, this is very important for us to know holistically how IoT can receive the connectivity. Okay, see, this is one diagram that describes, the wireless networks. See, this is BAN, and we have to use W before that to describe that this is the wireless network. And we have to use W everywhere. Wireless body area network, wireless personal area network, wireless local area network, wireless metropolitan area network, wireless wide area network, and global coverage. See, they are the various levels of the wireless networks. But we need to understand, why do we really want to know about the various levels of these wireless networks? What is the significance with respect to IoT? The significance is, sometimes you will find devices are in very close proximity. Sometimes the devices could be at slightly far apart, even farther apart, and even in a very wide area. The devices can be, and they need to be connected to communicate between them. And sometimes we will find the devices need global coverage. Okay, so see, what is important thing we need to understand from here is, we have to see at various levels, and levels means they are going to be defined in terms of the distance they are going to provide the coverage. The range, they're going to provide the coverage. Okay, so in terms of that, we can classify the wireless networks at various levels, but knowing only this is not enough. We need to know under which, what are the various possibilities, what are the various things available to us to create the wireless networks. Okay, so in order to know this, I'll show you the next slide. But before that, let me tell you, if I ask a question to you, where is my focus from here to here? Okay, see, you will understand even though I'm talking about the various levels of the wireless networks, but my focus will be in wide area network. Because when you talk about the cellular communication system, 5G represents the cellular communication system. This is falling within the wireless wide area network. So my focus will be here, but a glimpse we are going to go through that is related to smaller to the biggest one. And we will be knowing that what are the various systems, what are the various standards we are going to use for each one of them. Okay, so let us understand this. I'm going to discuss with the help of the next slide. Here we can say the body area network, wireless body area network. See, NFC represents is basically the short form of near field communication. And near field communication, it talks maybe in the range of 10 centimeter or so, very close. So basically, when you find devices close apart, they're very, very close in a very smaller range. If they are located, if they need to be connected, then body area network is one option for them. We need not to go for metropolitan area network or wide area network. And NFC is one, that is near field communication, maybe 10 centimeter or so, something like this. Okay, but let us understand, when we talk in terms of the technology, no statement is ever final. Time will change, research findings will change, and we will find the statement which I have made today, maybe after 2 years, the statement does not remain valid. But as of now, we need to know this near field communication, almost in the range of 10 centimeter or so, is going to work. Okay. See, when you talk about the personal area network, then we find the various networking devices available today are, see, you are aware of each one of them. You are aware of the names of each one of them. One is known as the Bluetooth. One is known as Zigbee. One is known as ultra-wideband communication. See, we are aware of all these, but let us understand how far. See, here I would like to say the body area network is for 1 meter of range. But when you take the basic example of the near field communication, this provides support for 10 centimeter of range. Okay. See, when you talk of the personal area network, this is in the range of 10 meters. Okay. So if you want to provide networking between devices, okay, in the range of 10 centimeter, then these are the 3 options available to us today. But why 3 options? Why not 1? Because all these 3 are not giving the same features. I would say, see, Bluetooth gives one specific data rate. Zigbee gives much lower than that. This gives 1 megabit per second, and this gives 1/4 of that, 250 kilobits per second, and this gives much higher. So basically, in a smaller range, within the 10 meters of range, if you want to provide networking between the devices, and if you want to really realize the higher data rate, then you cannot go for Bluetooth and Zigbee, you have to go for the ultra-wideband communication. For a smaller range, of course, the range is same, but for a smaller data rate performance, if you want to choose, you should not really choose ultra-wideband. For the smallest one, you should choose Zigbee, because this gives very small data rate performance, 250 kilobits per second. So we understand the options. Let me tell you one thing you know already, and you can envision, you can visualize, you understand the world is going to be embedded with n number of devices surrounding us, and devices are intelligent. Devices are smart. Devices talk to each other. The device could be small or device could be big. It does not matter, but the devices surrounding us will be smart and intelligent devices, and any device that becomes smart and intelligent, this needs to communicate. And when we are in the smaller range, then these are the various networking options we have. See, there is no 5G here at all in this. See, when you talk about the local area network, we know the range is limited to 100 meters. And we have various options, like we have the Wi-Fi, wireless local area network. The very, very commonly known example of the Wi-Fi of wireless local area network is Wi-Fi. Wireless fidelity. See, recently, the work has been carried out related to the light fidelity. The only difference between these two, not only difference, there could be many more differences, but the major difference we need to understand between Wi-Fi and Li-Fi is that this works on very high range of frequency. visible light of frequency, which will range of frequency this works. And you understand when you are going to go for very, very high range of frequency, what is the impact? Impact is, see, you will be able to realize much higher data rate performance because this relates to the bandwidth. When the bandwidth is going to expand, you know, by Shannon's equation that the capacity will increase, the data rate performance will increase. So basically, this is going to provide very high data rate performance compared to the Wi-Fi and RFID radio frequency identification. We are all aware. So basically, in local area network, in local area, if you want to provide networking, then these are the various facilities available to us for providing communication facility or networking facility to the devices. Okay, now let us understand when you talk about the metropolitan area network. This is limited to 100 meters and metropolitan area is in the range of 50 kilometers, much higher compared to this. WiMAX is one option. When you talk about the wide area network, see, it is not 50 kilometers. It's not limited to range, in fact, because when you want to use 3G, 4G, 5G, and whatever cellular communication system, if you want to use, see, you're not limited really to range. You can talk to any extent, any distance. Okay, so when you talk about the wide area network, means we are talking about here, we are talking about very, very specifically related to the cellular communication system. Today, we are talking about 5G. We have started talking about 6G also. And some time back, we worked on 4G. And even before that, we worked on 3G. And when you talk about the IoT devices today, when the IoT devices are going to take the help of the cellular communication networks, then we have these three options today. And when we have all these three options today, let us say, available simultaneously, and if we have to choose one, definitely we are going to choose 5G. Regions are very obvious. This is the advanced version of all these, and they have not considered IoT in more detail, and this has considered IoT in very, very much detail. So if we want to work for IoT, then definitely 5G will be one of our options. It will be the option within cellular communication. Okay, now I would like to go back to the slide, and then I will maybe in a fraction of second, not second, maybe 2-3 seconds, again I will come back to this, but I would like to say, see here, this is, there will be 29.3 billion network devices. This is one of the projection by Cisco by 2023. And by 2025, Ericsson said that 5 billion IoT devices connected to cellular networks. Now you can understand very well why this difference, 29, and even after 2 years, it is only 5 billion. But why? The difference is, you can understand, because when you really want to provide connectivity, it is the body area network limited to 1 meter of range. It is the personal area network limited to 10 meters of range, 100 meters of range. So these many different devices we have, not devices, these many different kinds of the networking possibility. These are the different kinds of the connectivity providers we can have, the various systems and standards we have, and all of them are going to provide connectivity to the devices. So you can very well understand this now that, see, even though this is 29.3 billion, but from the cellular networks, it will be 5 billion. That means you can understand connectivity will remain, connectivity will be there, but they will be provided by some other means also. Okay, and what are the various means? We have already seen here. See, if we want to provide coverage, global coverage, okay, then satellite is the means for us. So satellite, we can provide the connectivity. So let us understand, but why I have drawn this bigger picture of 5G? Only the reason is that out of all these options possible to us, we are going to focus on 5G. This is the 5G we are going to focus. Okay, now let us understand, if we are going to talk about 5G, then how we have come to 5G? This is not a new question. See, whenever you might have attended any workshop related to the next generation of communication system, see, almost all the workshop, next generation communication system, or even 5G, 4G, 6G, most of the time people start talking from 1G and finally they come to the 5G. This is not my purpose, okay, because I have 1G to 5G, but this is not my purpose. My purpose will be clear here after I come to this point. I would like to say, I want to discuss why we have come to 5G from the starting one. And when we have come to 5G from 1G, then what difference we are able to realize? And if we have come to 5G from 1G or maybe all the intermediate stages, then what facilities we are able to harness? See, this we need to understand. And we are going to start the very, very first day when even 1G did not really come. 1G came into existence in the year 1979. The very first standard of 1G were deployed in Japan by NTT, and that was in 1979. Okay, and I'm going to take one example even before that. Okay, and this example is, see, Martin Cooper on 3rd April 1973, he spoke these lines. He said, I am calling you from a cell phone, a real handheld portable cell phone. See, let us understand the situation. See, you have to go back in your imagination in this particular year, 1973. See, 1973, there was no trace of any standard of any generation of mobile cellular communication. I said the first generation came in 1979. In 1973, there was no generation of mobile cellular communication at all. But there is a word. I am calling you from a cell phone, a real handheld portable cell phone. Martin Cooper said this. Once there was not even a single, the first generation of cellular communication was not there, then why did he use the term? Let us understand. Demand of the mobile communication increased enormously. Even though the quality was not very good that time, still the demand increased. The reason is very obvious, because we do not really want to talk by being bound to one specific place. We want to move freely and talk. This is the convenience that was given by the mobile phone. And demand increased enormously. And a point came when it became impossible to provide services to the desired users, to the users who desired this. So there was some thinking that how to really solve this problem: frequency congestion, limited spectrum, and very large number of users. Then they came with the concept, you are very much aware of this concept, that the concept is cellular concept. Okay, so in cellular concept, in the year 1970, basically the concept emerged, and they could be able to realize something in 3 years, and this was the situation. And in fact, when the concept comes to mind, and when it comes into the form of a project, in the form of a product, see, there is a gap. And in this gap, a standardization has to be fixed, and based on those standards, the product is to be created. So that is the time that took place after this. And finally, in 1979, we experienced the first generation of mobile cellular communication. But in this particular time, see, now today, you can hold the small, very small size mobile phone. But when this was spoken, the device was Motorola Dynatac. Weight was 1.1 kg. Okay, you can compare. And the price was very, very high, almost in the range of 6,39,000 rupees. That was the cost. See, even though the cost was very high, definitely it has to be high, because that was the moment when it was ignited, that we are thinking about the generation of the mobile cellular communication, and we are going to create the first generation of mobile cellular communication. We had these many things, but the developments have taken place one after the another, year after the year, and then we have reached to a very far distance we have really reached. And what is the distance? I'll discuss with the help of a slide, slightly, maybe after 1 or 2 slides. With this, the moment was ignited. Okay, now let us understand. When you talk about moment was ignited, means the birth of 1G was taking shape. Okay, now why this slide? Very important slide for us to know. Not for the information written here. Okay, the information is here. 1G was analog, only voice, data rate was 9.6 kbps. It emerged in 1979. See, this information is not worth for this particular slide. This is very commonly known and everywhere spoken. See, 2G was digital, data rate was this. Then 3G became the first broadband, mobile broadband. the true mobile broadband could be realized by 4G, and today we are talking about 5G. Okay, but why this slide? A very important slide for us to understand, to take messages from this. Let us say 1G data rate was 9.6 kilobits per second. Okay, let us make this figure round, and let us say the data rate was 10 kilobits per second. Okay, and now what is the data rate of 5G? That is 10 gigabits per second. What is the difference between these two? See, you will find the difference is 10 to the power 6 times, such a great difference. And you know, whenever you use any communication device, when you use the mobile phone, it is the data rate performance that determines the kind of services you are able to harness from there. If data rate is very low, say you will be able to access only the smaller services, very primitive services. But if the data rate is high, maybe some more services you will be able to access to that. So one difference we can understand, the data rate performance from 1G to 5G over a period of how many? This is 21 and 20, almost 40 years. We can find over a period of 40 years of time, the data rate has increased in mobile cellular communication systems 10 to the power 6 folds, 10 to the power 6 folds, 6 times, so big. And this has made a lot of difference in the performance. See, today you can hold mobile phone in your hand and you can do as many activities you like. And let me tell you, the amount of features, the possibilities, the services available in your mobile phone, hardly there is a possibility that you can be able to exploit all of them. So you can understand it is only the data rate that has made it possible that from the very primitive start, we can come to this stage. Now, why 5G? See, we are going to talk of the billions of devices those are going to get connected to for IoT. Can you imagine a situation when we are in the age of 2G, when we are even in the age of 3G, 4G? Can you imagine the situation that IoT could be possible? See, it cannot be possible because IoT requires in small chunks. This requires enormous amount of data flow. And this data flow could not be possible here, or anywhere. So if your topic is IoT in 5G, you need to understand it is 5G that is able to realize IoT, and it is IoT that is going to make it possible to realize the features of 5G. Both are so intimately interrelated, you cannot think 5G without IoT, and you cannot think IoT without 5G. Okay, so this is one very important thing I wanted to say. There has been so much of improvement in the data rate performance, and because of this, so much of additional features, facilities, services, and applications are possible because of this enhancement in the data rate performance. Okay, this is one thing I want to say. But another thing I would like to say, you have already seen from 1G to 5G, there has been increasingly change in data rate performance. Data rate has always changed, improved. Every generation, like this is 9.6 kbps, this is 14.4 kbps, this is 2 mbps, and this is 100 mbps, practically realizable, although it was theoretically envisioned that 4G will give 1 gigabit per second in low mobility conditions in downlink. But practically, when you really realize, this is not more than 100 megabits per second. Of course, this is written for high mobility, but I'm talking about even in stationary conditions, this gives us the speed almost in the same range. Okay. See, what I want to really say here is that there has been enhancement. There has been enhancement into the data rate performance, but let me tell you one thing very, very clearly we need to understand. Motivation behind 5G is not only enhancing the data rate performance over the previous standards. This is going to give us a very new concept related to the mobile cellular communication. And what is that new concept? Maybe we will understand with the help of a few more slides after some time. Okay. Now, but data rate performance, enhancement in data rate performance has ever been the greatest motivation to go for the next generation. But why it has been? Because there is a term I would like to define. the user's experience. When you have the higher data rate performance, you are going to realize much higher experience, much better experience. If data rate is low, your experience to deal with the system will be poor. If data rate is high, you will feel good. You will have good experience. How? I would like to give this with the help of one example. And this is this example. Okay, this example says, see, behind the enhancement, behind going towards every next generation, enhancing the user's experience has been the prime motivation. And how it is realized? Because user's experience will be realized when you are able to provide the higher data rate performance. And with the help of this example, I would like to clarify how the experience is really changed, how the experience is influenced by higher data rate performance. See, let us take an example, 3 hours movie. Let us take the example of Titanic. Okay, if you want to download that movie, maybe the data, total amount of data in that movie is in the order of 1.5 gigabits. Okay, if you want to download this movie, and let us say we are into the old time when we use the standard dial-up modems that used to give 56 kilobits per second data rate, that was the maximum limit. So when you want to download the Titanic movie with the help of a standard dial-up modem, you will find it is going to take 7 hours, 26 minutes, and 24 seconds. There was a time when we found some enhancement and the data rate became 256 kilobits per second. For this, we used ISDN connection. When you use the ISDN connection, you will download this movie. It will take 1 hour, 37 minutes, and 50 seconds. See, we moved further towards 3G cellular communication system. The data rate is 2 megabit per second. See, 3G data rate is 2 megabit per second. So when you go to this, you will find it is going to take 12 minutes and 30 seconds to download this movie. When you go for Wi-Fi, where is the Wi-Fi? See, you've already seen it is a local area network. So when you are going to use Wi-Fi, you will find the highest data rate in Wi-Fi we are able to realize is 54 megabits per second. When you use this to download 3 hours movie consisting of 1.5 gigabit data, you will find it is going to take 28 seconds. See, I have not gone further. I'll discuss further slightly, but let us understand. See, the movie is the same. Work is the same which you want to do, you want to download. But because you have the different kinds of the systems, standards, giving you different data rate performance, it is going to take different amount of time, and you won't really like to watch that movie after 7 hours, 26 minutes of downloading time. Experience is extremely bad. It takes 28 seconds. Say you would like to download, you will feel good about the system you are using, the communication system you are using. But let us say, when we talk about 4G, the theoretical data rate performance of 4G is 1 gigabit per second. When you are using 1 gigabit per second and you are using the 1.5 gigabit data, if you want to download this, it is going to take just 1.5 seconds. How your experience is enhanced. See, when you talk about 5G, that assures. See, assurance is one thing and practically realizing is another thing we know in the technological domain. Unless you think for a higher value, unless you set a higher goal, see, will you be able to go into that direction? So we have 5G, 10 gigabit per second and even more. So you will find if you want to download this movie, it is going to take just a fraction of a second. How is your experience? You can understand. One point from this slide, I just want to show, of course, I have taken one example, but all these examples and from this slide, I just want to emphasize in only one point. See, enhancing data rate performance has always been the greatest motivation for going towards the higher generation. Reason is we wanted to enhance the user's experience. When higher data rate performance is realized, the user's experience is going to be enhanced. Okay, so this is one thing I just wanted to talk from with the help of this slide. Now let us understand 5G. Okay, I talked here 4G, I talked here 5G. It will take fraction of a second to download. But behind 5G, who is behind 5G? What is the vision of 5G? What 5G wants to really do in the field of communication? And who is responsible to envision about 5G, and who is responsible to really create the standard for 5G? See, we need to know this. See, ITUR vision. ITUR, International Telecommunication Union, radio section. Okay. They used to envision what should be next. So in the year before 2000, they envisioned next generation communication system, and that was 3G. And very popularly, this is known as IMT Advanced, IMT 2000. See, after some time, when we were almost onto the phase of realization of 3G, before realization started, even slightly before that, they have envisioned 4G, and the name they have given IMT Advanced, International Mobile Telecommunication Advanced. And in 2012, see, 4G was standardized in 2012. And in the same year, ITU envisioned for the next generation communication system, cellular communication system, and this is 5G, and the name IMT 2020. Okay, so what is 5G? We know who envisioned. ITUR has envisioned. Let me tell you, across the world, there are two different kinds of the organizations. One that sets the vision, but does not realize that. And another one that realizes that vision. Okay, so for example, I would like to say ITUR sets the vision. It says what should be in the coming days, but it does not create the technology. It does not develop the standard. Like 3GPP is one example. IEEE is another example. So these are basically the bodies. They create the standard. They will see the vision of ITUR and they will develop the system according to this vision. So ITUR envisioned this, and it was envisioned that the deployment will take place in 2020. It does not mean that it is in 2020 only, but definitely 2020, 2021, 22, 23, something like this, the 2020s. Okay. Now let us say, but of course, the deployment has already started in 2020 in some part of the world. Okay. Now let us understand, when ITUR has set the vision of 5G in the form of IMT 2020, then what 5G is? 5G provides a new path for thinking. See, I said here that all these are going to show you enhancement in the data rate performance, but 5G is different in one aspect. It definitely shows the enhancement in data rate performance, but it is not limited to that. It provides a new path for thinking. This is the difference. Okay, and 5G aims for anybody, anything, anywhere, anytime, anyhow. See, let us understand, we have to derive something out of these lines. Aims for anybody. Now, this is not anything new for the communication system, let us say, because so far we have developed the communication system, keeping the individuals, keeping the man, keeping the human being in mind. See, the communication system should support the human being. Support in a sense, whatever human being is doing, it should enhance that performance. But let us understand, when you're not limited to anybody, if you're going to go to anything, there evolves the machine-to-machine communication, there evolves the IoT. Anywhere, not limited to place. See, there is no limitation of time, and there is no limitation of the technology by which we are going to use to provide the service. Anyhow, it simply means that, see, we are aware of the term heterogeneous network. What does it really mean? At the same place, at the same time, we will find not only one network, but variety of networks available. And if the device is a smart one, the device will choose out of 10 networks, it will choose which one is best possible for me to use in terms of the amount of money I'm going to invest or in terms of the quality of service I'm going to get. So basically, this is not limited to one kind of the multiple access technique. This is not going to depend on only one kind of the radio access technique, but it is going to choose the way it wants to. So let us understand, you find there is a difference in 5G compared to the all other standards. Anything means we start with machine to machine, we start with IoT, not limited to human being talking to other person. Okay, now let us understand, when we talk about this, then we would like to see what is the difference in 4G and 5G. Because we have seen, we have grown towards 5G with a very simple vision that we are not limited to just enhancement over the previous standard, but we are going to do something new. And if we want to do something new with the help of the 5G, then we have to really understand, we need to really compare the features we used to realize in 4G, and we are able to realize, we will be able to realize with the help of 5G. We need to understand this. Okay, so for this, one comparative chart, one comparative diagram is very important for us to give a clear understanding. And let me tell you, I am not the creator of this diagram. I have not fabricated, I have not created this. This diagram is very, very commonly available everywhere when it is talked about 5G, because this diagram gives a very clear and very, very simple picture about the enhancement over 4G in terms of 5G. This is the reason that this diagram has been preferred across the world. In many publications, many papers, even the books nowadays coming, you will find this figure has been preferred. The reason is very simple. This gives simplicity of understanding. So if you want to compare 4G and 5G, then we will find that, see, when you want to compare 4G and 5G, then we have to decide the parameters on the basis of which we want to really compare. So there are 8 parameters we are going to choose to compare 4G and 5G. One is the peak data rate, one is cell spectral efficiency, mobility, cost efficiency, connection density, energy efficiency, latency, and cell edge data rate, data rate performance. These are the features, but let us understand. Maybe I would like to devote 2-3 minutes on this to explain what does it really mean and how does it really make a difference between these two. See, when you talk about the mobility, if you talk about 4G communication system, mobility is limited to 250 kilometers per second. Let us say you are in a train. Of course, we do not have any train in India that runs at a speed of 250 kilometers, but let us say you are in a train somewhere that is running at a speed of 250 kilometers. See why I'm talking example of train? Because see, on the ground, I don't think that there is any other option by which we can travel with this speed. Okay. So let us say you're traveling with the help of in a train. If it reaches 250 kilometers per hour, then you will find the 4G connectivity is going to work. But the moment it is going to cross the kilometers per hour, 250 beyond, see, 4G will not support your communication. But 5G will support. This is one of a feature 5G is going to give us. It will support up to 300 to 500 kilometers per hour speed. See, let us understand what is the meaning of the term cost efficiency. See, by simple meaning cost efficiency, we understand you put the amount of money to receive the service, the amount of service you are going to receive, and the amount of money you are going to invest for that, you will find the ratio of these two is going to increase. It means that you will have to invest a smaller amount of money to realize higher amount of service. Okay, what does it really mean? See, because you know, 5G is going to give you so many different services, but at very high data rate performance. And if you have to invest money in proportion, so you won't really like to buy the services from 5G. So you will be able to buy variety of services in 5G, and comparatively 4G, you will find that the cost is lower. And this is 50 times lower. See, this is one of a difference we can find. See, connection density, very heavily dense. Just in 1 square kilometer area, you will find the number of connections possible is 10 to the power 6. So many connections are possible in 1 square kilometer area. So you understand the density of the users will be extremely high. See, let me tell you, these features will not be simply like we know this is going to be, but we need to understand how it will be possible. And there are technologies behind everything. See, let us talk about the energy efficiency 10 times. It simply means that if you are using battery power for 4G, and if you're using for 5G, see the efficiency 10 times means it is going to run for 10 times more, means 90% of the power saving is possible in 5G. So when you talk about the green communication, this is one of the very special advantage we can say in 5G we will be able to realize. See, latency 1 by 10 times. See, there are two different kinds of latency we understand from the technological point of view. One is air-to-air latency and one is end-to-end latency. So 4G gives end-to-end latency 50 milliseconds and air-to-air latency is 10 milliseconds. That is the figure we know about the 4G. But when you talk about the 5G, the latency is going to be reduced 10 times. See, whatever is 50 milliseconds will become 5 milliseconds, and whatever is 10 milliseconds will become 1 millisecond. And let me tell you, the very, very important feature, the most important feature of 5G is evaluated in two terms. One is in terms of latency, and one is in terms of the data rate performance. If some system we are able to develop, and this is going to give us a peak data rate in the range of 10 gigabits per second. And at the same time, if the system is going to give us a latency 1 millisecond, we can call this system as the 5G. So far, there is no such system. Okay, cell as data rate. See, this is such a kind of a unique feature. This needs a little technical understanding to know what is the uniform experience. See, technical, we all are technical people. So it is not that it needs technical understanding. So this is some word that is away from our discussion. I would like to say that in order to know the uniform experience, whatever terms we have been using so far, it is slightly different from this. See, uniform experience, what does it really mean is, see, when you have a cell, okay, at the center, you know there is a base station. If the user is close to the base station, user will receive good quality signal because the distance is small. Interference coming from the outside is small. And the signal is traveling for a smaller distance. So the higher magnitude of the signal is being received. So as the user is going to move away from the center of the base station towards its edge, you will find its quality is going to degrade. That means if the user is here, or anywhere, according to the distance from the center of this base station, the quality of the channel or the signal to noise plus interference ratio, you will find is going to fall. If it is going to fall, at every point, whatever data rate it is going to realize will be different. We know very well, when you are at the edge of a cell, you will receive the minimum amount of data rate. When you are close to the cell, center of the cell, you will receive the maximum possible amount of the data rate. We know this concept. It means that at every point, we are not going to get the same amount of the data rate, but 5G says cell is data rate is going to have the uniform experience. That means either you are here or here or here. It makes hardly any difference, but whatever data rate you are going to realize, it is going to be uniform throughout the place, throughout the cell. See, this seems a very new concept, because whatever we have seen, whatever we have understood, whatever we have known so far, it simply says the moment you go away from the center of the cell, you are going to reduce, you're going to experience the lower data rate performance, but it is contrary to that. And in order to realize this, this is one of a very important feature of 5G. And in order to realize this, we have to work on some technological aspects. And then it is possible that we will be able to realize. So these are the various things. See, I had just, this slide only says that peak data rate 4G, say here it is 10 to 50 gigabit per second, but practically we realized hundreds of megabit per second only. although theoretically it is 1 gigabit per second in downlink. So likewise, cell spectral efficiency will be 10 times here, and whatever cell spectral efficiency we realize in 4G is in the order of 1 to 3 bits per second per hertz. Mobility we have talked, and air latency we have already talked. And 5G is going to give us the energy efficiency 10 times higher. Okay, we know. See, let us talk about some very specific features we are going to realize with the help of 5G. Availability will be 100% in the coverage region. See, you will not find the moment when you will find that you are not connected. You will find it is always available to you. Whenever you want to get connection of the 5G services, it is always available in the coverage region. Definitely in the coverage region, because out of the coverage region, you will not get connection. See, lower outage probability we need to understand. 5G ensures lower outage probability, means the signal will go below the standard, below the required minimum, very, very less amount of time. This probability is very low. And what does it really mean? It simply means it translates into higher reliability. When the outage is low, the reliability will be simply high, because you will not find droppage of the signal. That means signal is available to you, it is reliable. Okay, high connection capacity, definitely we have seen that the density, connection density, that means 5G will be able to support that connection density, that is the capacity. High mobility we have already seen, and including high definition quality mobile television also. Low, very low latency we have already seen, but we need to understand when the latency is very, very low, we will be able to realize very high data rate. Latency simply means that the amount of time it takes from point of transmitter to the point of receiver. If the amount of time is more, that means the data rate performance will be low. If it takes very small amount of time, you can very frequently transmit data, that means the data rate will be high. Very low latency means it is very high data rate, and we want to realize very high data rate. Large coverage area, low cost services, secure communication, and low power. These are the various features of 5G. But why I really want to talk about these features? Because I would like to move to, I would like to go to this particular slide. And this is the reason that I want to talk about the various features, the various possibilities the 5G is going to provide to us. Okay. Now, before going to that slide, I would like to show two more slides. Okay, this is one slide which talks about the various usage scenario we are going to realize in 5G. See, this diagram is released by ITU. Okay, they have drawn this diagram and they have made it public, and everywhere nowadays, whenever you describe the usage scenario of 5G, a reference of this diagram is taken. Not exactly the same way, the diagram will not be drawn, but the basic remains the same. That means we can see a triangle, and on the vertices, we are going to see three different kinds of services. This is enhanced mobile broadband is one of a kind of the service. See, what I want to really say is, when you talk about the 5G, see, we will find out where IoT is in this. Okay, see, when you talk about the enhanced mobile broadband, when you talk about the services offered by 5G, we can keep them in three categories. Three categories, why? Because every category is going to give us a very different kind of features, different from the other one. Okay, very special kind of a feature, different from other one. And we need to understand. One vertices is this, one is, see, this is MTC, this stands for massive machine type communication, and this is ultra reliable low latency communication. So basically three different kinds. And see, these services are not basically from one specific kind. So basically 5G is going to provide all these kind of services, and any service will fall into one specific category. See, we will have 3D video, ultra high definition screen, work and play in cloud, augmented reality, industry automation, mission critical applications, self-driving cars, gigabyte per second data flow, smart home, smart city, and voice communication. Basically, all these services are going to be realized with the help of 5G, and one of the services may fall into one of the category. Let us say when you talk about the self-driving car. Okay, then we have to identify where it is really going to fall. When you talk about the smart city, then we have to identify where it is going to fall. And in order to identify this, we need to know in little more details what these individual services are having specific features. Okay, so let us understand when you really talk about the enhanced mobile broadband, this what is. Okay, then you will say enhanced mobile broadband means we are talking about extremely high data rate. Whenever there is a very requirement of very large traffic capacity, then the kind of service falling into the category of the enhanced mobile broadband offered by 5G, that will fall into this. When you talk about the mobility conditions, okay, see, ultra reliable low latency communication, ultra reliable, very high reliability whenever there is a requirement. And we will know where such requirements are. Less than 1 millisecond latency. Then secure communication and mission critical applications. We will find the kind of what is we are going to use here. This is going to support these kind of services. Okay, so mission critical application, you will find there is one example written here, mission critical application. So you will find this is falling here. Okay, see, when you talk about massive machine type communication, then low power and cost, large coverage area, low data rates, large contention density, and low complexity. Okay, see, I have a very specific point to mention here. When you talk about the IoT, IoT is falling under the category of massive machine type communication. Definitely, by name itself, you understand machine type. We are talking about the devices communicate. Devices communicate to each other, and maybe most of the places we do not really require the human intervention for the machines to talk, to devices to talk. And let us understand massive machine type. We are talking about the billions of devices connected tomorrow, and lot many devices already connected today. So basically, when we want to use 5G, then the kind of category of the service in 5G that is falling under mobile, that is falling under massive machine type communication will support the IoT. So one thing we have very clearly known that when you talk about IoT in 5G, 5G has provision for IoT because IoT requires low power. See, most of the devices are scattered here and there, and they don't really require very heavy cost, even for the devices and even for the communication. See, they are going to cover a very large area. And whatever communication is going to take place between the devices, they are not broadband. They are very small amount of data rate has to flow. Let us say when you really talk about the example, when you have the computer peripherals, that means when you have the mouse, you have the printer, you have the headphone connected to the computer, the keyboard. See, the data rate required to communicate among them is only in the order of 115 kilobits per second. It's not megabit per second. It's not gigabit per second. 5G ensures a gigabit performance. But when you talk about the massive machine type communication, individual devices are going to communicate at very low data rate, large connection density, and low complexity. So these are the features that is going to support IoT communication. So we will find here smart homes, smart city, all they require IoT. When you talk about gigabit, this does not require IoT. When you talk about the voice communication, this does not require IoT. Okay, see, this does not require, see, this will require. And likewise, we can understand, okay, I'll take the example of self-driving car and then I will move further. Okay, see, let us understand self-driving cars. If one individual is driving a car, human being, okay, if some problem comes suddenly, see, it needs a response time to react to the situation and provide a solution to overcome the problem. Okay, and let us say when we are talking about the self-driving cars, that means car is being driven, but there is no driver there. It is self-driving car. Okay, so basically two situations. One is one individually driving a car, and another one is the car is self-driven, and both of them are coming across the same obstacle, the same problem, the same situation. Okay, and in order to react to the situation, both of them requires the response time. Normally, what feeling we have is when the individual is sitting in the car, it may respond in a better way. It may respond quickly because the things are there in front of the person. But machine-to-machine communication, the IoT has made this statement wrong. The reason is because one individual will react in 200 milliseconds of time, whereas we are talking in 5G sub-milliseconds latency. That means less than 1 millisecond for reaction time. So when less than 1 millisecond is the reaction time compared to 200 milliseconds, you will find that the decisions are taken much faster. So self-driving car is based on this particular concept. Okay, so we are moving towards the next one. We have seen the user scenario, the various names. Under these, what are the various features, capabilities? And we have seen that this is the machine type communication of 5G that is going to support the IoT applications. Okay, now, when we have all these, 5G is going to do all three different kinds of functions. See, 5G is going to support these many applications. And 5G is going to realize this 5G is really going to ensure all these. This is unprecedented challenge. Means the challenge which has never emerged before. See, the human being, those who are into the field of technology, those who are evolving technology have always faced the challenge. Unless you face the challenge, you will not come up with newer solution. This is very important thing to know. We have always faced the challenges. But why I want to use the term unprecedented is because the kind of challenge, the amount of challenge, the magnitude of the challenge we are facing today to create 5G, we have faced the challenge, but the amount of magnitude has not been the same. But why this? Because we want to meet the expected performance requirements. Whatever we say the 5G is going to do for us, in order to realize all that, see, we have to move to realize. And this is a challenge. In order to meet this challenge, what is important for us is that 5G needs support. Technological enhancement in 5G needs support. And in the form of the technological enhancement, we can say enormous upgrades are required. It means, see, whatever technology is already existing for 4G, the same technology will not work with the same magnitude. See, what I mean to say, same technology will work for 5G also, but the magnitude will not remain the same. It has to be enhanced enormously, needs a lot of upgrades to use the same technology which is used for 4G to be usable for 5G. But it is not necessary that whatever technology is already existing, the enhancement is going to support 5G, not necessary. Maybe some features of 5G are coming, are envisioned. The existing technologies will not support. In that case, we need to develop new technologies. This is the requirement for 5G. See, we require a network in 5G. The network should be able to accommodate large number of connections. Definitely, we have already talked about one of a feature of this is going to have a very large connection density. See, IoT kind of the services should be able to be supported by 5G, machine-to-machine communication, and ambient intelligence. Ambient intelligence simply means that where the physical world meets the digital world. So we need such kind of the ambience. Then remarkable changes the system architecture. One thing I would like to say, whenever you move from one standard to another standard, one technology to, see, not exactly technology, from one standard to another or one generation to another, you will always find it is going to involve some architectural changes also. When you talk about 1G, 2G, 3G, 4G, even 5G, you will find the architecture has been always changed because some features are changed. In order to meet those features, the architecture has to change. So we require architectural changes in 5G. So now let us understand. See, I've talked about the ambient intelligence. This is one of the situation that a 5G has to create. And what is ambient intelligence? We are all aware. See, this refers to an electronic environment of the embedded devices. the devices embedded in the network. See, this is context aware, aware of the situation, situational context of a person. See, this is personalized, tailored as per the need of the person. And this is adaptive, changes the response as required. You understand, smartness in the device is the most important parameter. Okay, this is anticipatory. It can make, the devices can anticipate the next requirements. If we are able to create such devices, if we are able to network such devices, and with that, whatever environment we are creating, whatever ambience we are creating around, that is known as ambient intelligence. And you know, it is the IoT that is going to create the ambient intelligence. We know this. Okay. Now let us understand, in order to support, what are the various enabling technologies for 5G networks? These are the situations we are going to realize, okay, in 5G. And in order to realize these situations, we have to face the challenges. And challenges are in the technological domain. And we need to know what are the various enabling technologies for 5G networks, for 5G. Okay. See, there is a big list. We will talk about few of them. List is network function virtualization. Is very important factor. We have to talk in terms of 5G. 5G has given a lot of focus for this. I'll discuss what is this. And network function virtualization becomes realizable only with the help of the software-defined networks. So in my presentation, I have combined both of them together, and I have made 2 slides to discuss network function virtualization and software-defined radio under the category of, the slide is basically software-centric network. Okay, so these 2 are discussed in 2 slides. Then we talk about the millimeter wave communication. Then we talk about improved multiple access schemes. Then there are a number of other technologies. Those are under consideration. But why I have focused all these? Because they are more close to understanding the IoT applications, and they are not exactly related to the IoT applications, like massive MIMO, waveform design, cognitive radio networks. So many, some of them could be, but all of them not. Okay, so but basically, looking at the paucity of time also, I have discussed that only these technologies I will discuss. I have decided we'll discuss. Okay, and let us see how far we are able to discuss now. So these 2 are discussed under the heading of the software-centric network. See, when you talk about the network function virtualization, implemented with the help of the software-defined radio, then it is going to lead to a kind of a network, and this network is known as software-centric network. Okay, so in the first I have discussed about network function virtualization, and in the second I have discussed software-defined radio, software-defined network. So you can see these 2 are discussed in these 2 slides. See, software-centric network, you understand the name itself. Now the network is not going to be manually handled. Now the network is not going to be based on one specific kind of the hardware platform, but we are going to make it possible with the help of the software that the network can function in different manners as really desire and require. Okay, so first let us understand what is network function virtualization. Virtualization has become very, very important today. As the number of devices are growing very fast, virtualization is very important aspect. Okay, so let us understand virtualization enables separation of hardware from software, or you can say function word is used here. So you can say it enables hardware functions from the software functions. It does not really matter. Only thing we need to understand, hardware and software parts are not the same, not integrated. They are separated. This is one of a very important feature of network function virtualization. And after that, we need to know the network infrastructure becomes independent. Because of this separation, the network infrastructure becomes independent of the service providers. It is not necessary that the service provider has to create the network infrastructure and then provide the service. Not necessary. These 2 are independent to each other. Service provider can dynamically share. Now, once the network has been created, it is independent of the service provider, means the same network can be dynamically shared by different service providers. See, network function virtualization enables this. Okay, now let us understand minimizes network utilization, maximizes network utilization, because of the coexistence. Same network can be used by so many different service providers. That means network utilization increases. Allows different services to coexist. Simply, we can understand there are various different service providers providing different services. Same network can provide different services. They can coexist. Requires use of, okay, now when you want to really create all these features and possibilities in the network, it means this is required to be supported with the help of the software-defined networks. Okay, so what is software-defined networks? This helps in dynamic configuration, radio resource management, network slicing. It enhances quality of users' experience. It offers manageable means to monitor network. It supports new features, rollout, network relocation, etc. So many different functions we can realize. And when you do this, say the OPEX, the operational expenditure, and the CAPEX, the capital expenditure, the investment is going to lower down. When it is going to lower down, the advantage you can understand, see the cost will come down, these services will be available at the lower price, the users will be benefited, and at the same time, the service providers and the infrastructure providers will also be benefited, because then there is a margin to settle down. So basically, this is going to lower the CAPEX and the OPEX. See, operational expenditure also reduced by power saving. Why power saving? Because see, the infrastructure will be used only when it is required, otherwise not used. So there will be amount of power saving. So cost also is going to become lower. See, software-defined network offers cheaper and simpler network architecture, which is easy to upgrade and integration. See, this is what. Now, why I really want to show this slide to you is that when we really talk of the IoT, we have seen here, we talk 5G has a very great, very significant amount of functionalities related to the IoT. Number of devices in IoT is going to increase at a very fast pace. A lot of management and control among their functionalities, a lot of coordination is required in the network. The devices are embedded in the network, a lot of coordination is required. And when you want to really do a lot of coordination for the IoT devices, it is really not possible that by traditional method you will be able to do it. It is not possible. So you have to break the traditional method boundary and you have to choose some other solution. And this is the solution. See, software-centric network is the solution to provide control, coordination to the enormously increasing number of the IoT devices. Okay, now let us understand. Okay, see, now time is really about to be over because it is 3:25. And I think we have another 5 minutes as per the time schedule. So I would really welcome questions, because it is not possible that all the slides can be discussed, and it is not the purpose also. The purpose is we should be able to have some feeling and realization that how 5G is related to the IoT and what really we should know related to 5G and IoT. And communication coming from the cellular networks supported by 5G, how it will help IoT to get implemented. This was my purpose. And I think going through all the slides is really not necessary. And here I would like to stop, and I would like to welcome questions from your side, if at all you have questions, because another 5 minutes, I would like to finish according to the time given to me. Thank you for very patient hearing. And maybe you might have questions in between, but I didn't really find an opportunity to ask you to ask questions, because I thought I will ask questions only at the end. Okay, thank you. So I would like to show you the thank you slide at least. Thank you.
Thank you very much, sir, for such a nice and wonderful session. So there are a few questions in the text box, the chat box.
Okay. So questions are there in the chat box. I don't know why the chat box is not visible to me on my computer. So can you just read out the question from the chat box, and I would like to give an answer.
Okay, sure, sir. So the first question is how SDN and network virtualization may contribute to cut costs, but there remains uncertainty about to what extent this will speed up 5G rollout.
Okay, can you just repeat the question once again?
How SDN and network virtualization may contribute to cut the costs, but there remains uncertainty about to what extent this will speed up 5G rollout.
See, this is very clear for us from the description of SDN and network function virtualization. Together they are going to work. See, one of a very important aspect of this is now the network is not controlled traditionally. Now network is under the command of the software. See, this is one thing. Okay. See, when you want to talk about the cost cutting, then we have understood because of the network function virtualization, the software functions and the hardware functions are separated. Not only this, but the service providers and the infrastructure providers are separated. See, there will be one entity, one kind of the individuals, they will provide the infrastructure. There will be another kind of the individual, those who are going to use that infrastructure in terms of providing service. So you understand, cost will be minimized. Reason is very simple, because the service provider do not really need to create the infrastructure. It has to just pay some amount of money to use the infrastructure. And whenever it is going to use, then only it has to provide the money. So you understand the cost of the service providers is going to lower. The cost of the service provider is going to become lower. It means that, see, this is going to be affected. The cost of the consumers are going to be affected by this. So cost cutting is so simple. It is naturally, it has to take place. Another thing, rollout, how the rollout will be possible. Because we know when we talk about 5G, when you're talking about the IoT, when we are talking about the rollout of the IoT, rollout of the 5G with its IoT features, we know it is not simple. It is very complicated. And unless we have a very clear-cut software controlled mechanism, it will be difficult to roll out for the new features. Because one of a very important aspect of software-defined radio, I would like to say, with that reference, we can understand software-defined network. See, software-defined radio, we know the fundamentals of this. There will be one hardware. And if we want to really improve the hardware, it is not necessary that we are going to work with the hardware. We are going to control the hardware with the help of software, and whatever improvements we want to see, we can see with the help of the software, and accordingly we can create the final structure. So we know this. So rolling out becomes very easy when it is being controlled by the software. Sir, I think this is what my answer is related to the rollout and the cost cutting.
Sir, another question is there. D2D links potentially more vulnerable to privacy violation besides suffering from all the attacks affecting other networks. How we can ensure privacy and protection?
Yes, this is a very clear concern, let you. It is not related only to the 5G or not related to only IoT. When we moved from wired to the wireless communication, this question arose in our mind. Question why it arose? Because see, when you talk about the wired connection, security and privacy is not a very serious concern. Because if somebody wants to interrupt the communication, enter into the communication, see, it has to enter through the wires only, and it is not possible. But if you really want to talk about the wireless communication, the communication spreads in the environment, and anyone in the radio range of that wireless communication will be able to receive, will be able to tap, will be able to create some kind of the tampering to that information. And here the security comes. So when the wireless communication started getting evolved, the security has always remained a serious concern. And let me tell you, for IoT and 5G, this concern is even much serious, much deeper. And when you talk about the disadvantage part of IoT, this concern is the disadvantage part of IoT. That means there are a lot many devices, all are working in the radio communication system, mobile wireless communication system. And because of the wireless communication system, the security becomes the very prime concern. And definitely, we cannot leave any system with very security and privacy. So there are people, those who are thinking and working for the security and privacy of the IoT devices. They must be knowing the answer, that at what stage they are able to provide today. But from my side, the answer is, it is a really serious concern. And this is one of the disadvantages of the IoT devices. And solutions have to be sought by the technologists, those who are working in the field of security of information.
One more question is there. User mobility support in small cells, problematic applicability of centralized authentication protocols in MEC platform are big challenges. How we can address the issues?
Okay, I would like you to just repeat the question once again.
User mobility support in small cells, problematic applicability of centralized authentication protocols in MEC platform are big challenges. How we can address these issues?
Yes, see, see, whenever we talk of the any communication system, see, validation, that means the authentication is very, very important. Okay. And here, because we are dealing with large number of devices, extremely large number of devices, and whether they are concerned with me or it is concerned with somebody else, this authentication is really important, really needed. And it is not, because when you talk about the centralized system, like let us take an example of the mobile cellular communication system with a base station installed in the region of its coverage zone. And let us say we talk about the Wi-Fi, and the Wi-Fi is not having the access point, it is simply having connection in the distributed manner. So in both the situations, you will find there is a lot of difference in the security of information. There is a lot of difference in the authentication of the information. And people, those who are working in this area, must be able to address these issues. And it is true that the authentication problem will lie, but solution have to be found. And I think the people, those who are working in this field, they will be able to give the answer, what has been done and what is being done much more clearly, because see, this is really not my field. So I do not really know in terms of the authentication and security, how far we have worked in the area of IoT, but definitely from the communication point of view, I could understand something.
So the last question, as the 5G technology provides a number of features, so is it energy efficient, or we can say that is it a power saving technology?
This is not power saving technology, but this is energy efficient technology. Because see, in one of the slides, we have discussed that this is going to enhance the energy efficiency by 90%. That means, see, if you're using battery for certain application today, the same amount of battery power will be consumed for 10 more times of the work. That means in its system itself, the 5G is energy efficient. This is one thing. Second thing, let me tell you, when 4G was being developed, there was no very, very clear concept about the green communication. But 5G takes into consideration very, very seriously about the green communication. And when you talk of the green communication, that means you're talking about the energy efficiency. So 5G has this feature of energy efficiency, but it is not working in the power saving mode. It itself is energy efficient system.
So thank you, sir. This is all about. There are no more questions. So anything, Vandana madam? Anything from your side?
Hello.
Yes, madam.
Yeah, Sanjay sir, it is as usual a technical treat to listen to your session. So wonderful session. Thank you very much for accepting the invitation and joining us.
I thank you and both of you for inviting me for giving this talk. And I'm really pleased that I could deliver. And I believe it might be able to create some question in mind. If it is able to create some questions, I think our purpose is over.
Yes, sir. Yes.
Thank you very much.
How will you really work?
Yeah, thank you.
Thank you very much.
Thank you so much. Thank you. Thanks, everybody.
Okay, thank you.
Thank you.
Over to Annapurna, madam.
Thank you, sir, for the wonderful talk. It will really encourage our participants to explore more on pursuing research beyond 5G communication. On behalf of the entire FDP team, Thank you once again for being with us.
Thank you so much.
I request Pritam, please close this Zoom window.
Wait, sir, 1 minute, please.
Okay, sir. Okay.
With this, we have reached at the end of day 4. I hope all of you have enjoyed the sessions. I really thank the participants for such beautiful words of appreciation. Tomorrow, again, we will join with some more exciting talks from our experts, including one yoga session and the validatory session and the test. So I request all the participants to join at 9 o'clock tomorrow, the last day of our FDP. Till then, bye-bye.
Pritam, please.